The Mariana Trench is the deepest scar on Earth, a chasm so vast, so silent, so unexplored. It might as well be another world. At its bottom, the pressure could crush a submarine like a tin can. And yet, life persists. Not just strange life, but impossible life. Creatures that glow like stars in the blackness. Jaws that unhinge like traps in the dark. Eyes the size of fists, watching from a place no sunlight has ever touched. Some are real, filmed, named. Others have only been heard as metallic moans echoing through 7 miles of water. Sounds no one can explain. Not quite machine, not quite animal. There are sharks here that haven't changed since the age of dinosaurs. Squids with hooks instead of suckers. And fish so fragile they dissolve before reaching the surface. This is not science fiction. This is the Mariana Trench, the last true wilderness left on our planet. And the deeper we descend, the more it begins to feel like we were never meant to be here. So take a breath, turn out the lights, and come with me into the abyss, where monsters aren't imagined. They're simply undiscovered. Let's begin. The story begins not in some ancient past, nor buried in forgotten texts, but in 1976, a year not so distant. The world already had satellites in orbit. Computers hummed in government labs. The Cold War cast a quiet tension across continents. But beneath the surface of the Pacific Ocean, a new kind of discovery was about to rewrite what we thought we knew about the deep. Before we step into the next part of the story, just a quick note. You'll notice the visuals are subtle, meant to support, not distract. This series is built for quiet listening, researched slowly, spoken gently. So whether you're here for every word or just letting it play in the background, welcome. Thanks for being here. Now, let's continue the journey. It began on November 15th, off the coast of Oahu, Hawaii. The US Navy was conducting standard operations, towing equipment through the deep waters between the islands. Nothing unusual, nothing expected, until something unexpected caught. The cable dragging below their research vessel pulled taut, as though it had snagged on something. But there was no reef here, no wreckage, no known obstacle. The crew slowed the ship, reeled the cable in, and found something they never imagined. A massive, lifeless body tangled in the net. At first, they thought it was a basking shark, a species known to filter feed with its wide, passive mouth. But as they looked closer, it became clear this was no ordinary shark. Its body was massive, bulky, mottled brown and grey. Its eyes were small, almost disproportionately so, and its mouth was vast. A rounded, gaping maw with thick, rubbery lips that gave it a strangely soft appearance, as if it were made not for tearing prey apart, but for drawing the ocean into itself. It was over 14 feet long. Its mouth alone stretched more than 4 feet across, and no one, not the Navy officers, not the biologists later called in, had ever seen anything quite like it. They had just discovered a new species of shark, a giant, from a world we still barely understand. They named it Megaphasma pelagios, the megamouth shark. The name itself evokes something mythic, a creature from abyssal folklore. But this was no exaggeration. What they'd found was real, and it was alive, until moments before its accidental capture. It had died in the net, the only specimen in existence. The team quickly moved to preserve the body. Photographs were taken, tissue samples preserved. Its massive jaw was studied, measured, and documented. And as researchers began to understand the anatomy of this strange creature, a new mystery unfolded. This shark didn't fit into the typical categories. It wasn't a predator like the great white. It wasn't a bottom feeder like some deep-sea species. And it wasn't entirely like the basking shark or whale shark, the two other known filter-feeding giants of the sea. The megamouth was something else. Its body was gelatinous and soft, almost flabby, built for slow, energy-efficient movement. Its teeth were small and rounded, arranged in numerous rows, utterly unlike the jagged, tearing blades of a typical shark. And most bizarrely, its mouth glowed. Lining its lips and the inner surface of its jaw were patches of photophores, tiny organs capable of producing bioluminescent light. In the total darkness of the deep ocean, this glow would have appeared like a gentle beacon, or perhaps a lure, drawing prey in, or drawing something else. This was a shark adapted not just for survival in the deep, but for a life entirely unlike what we associate with sharks. It rose from the blackness like a spectre, and then it vanished again, because for over 8 years after that first discovery, not a single megamouth shark was seen again. No live sightings, no accidental catches, no photographic proof. Some biologists began to wonder if the first specimen had been a fluke, a one-off, a genetic oddity, a lone survivor of a long-lost lineage. And then, in 1984, it happened again, this time in California. A fisherman found a strange, sluggish shark swimming near the surface, its enormous mouth agape, its odd rubbery form pulsing as it moved. It was unmistakable. The megamouth had returned, and over the following decades, the sightings increased. But not by much. To this day, fewer than 300 confirmed megamouths have ever been documented worldwide. In an era of satellite mapping, deep-sea submersibles, and genetic barcoding, the fact that such a large creature can remain so rarely seen is both remarkable and unnerving. Most sharks, even elusive species, are spotted thousands of times per year. But the megamouth, it disappears and reappears in cycles that defy prediction. Its movements remain obscure, its habits largely unknown. Some have called it the phantom shark, not because it's supernatural, but because it might as well be. You can look for years and never see one. You can search known hotspots and return empty-handed. This shark lives in the deep, far deeper than where most marine surveys operate. And even when it comes close to the surface, it moves slowly, almost lazily, making it difficult to detect on sonar. It doesn't hunt like most sharks. It doesn't strike or charge. Instead, it opens its massive mouth and glides, filtering microscopic plankton, jellyfish, and small crustaceans from the water column. A predator of the smallest prey. And here's where things get stranger. Some deep-sea submersible footage, grainy, barely legible, has captured glimpses of megamouths rising from the depths during the night, only to return at dawn. This pattern is known as vertical migration. Each night, in the darkness, countless deep-sea creatures rise toward the surface to feed. And each morning, as the sun's rays begin to pierce the upper layers, they retreat back down, into the cold and the pressure of the abyss. It's the largest migration on Earth, by biomass, and it happens every single day. But it's invisible to us. The megamouth appears to follow this rhythm, which means it spends its life rising and falling through the water column, following ancient cues: temperature, light, magnetic fields, perhaps even sound. And still, no one knows how long it lives. No one knows where it breeds. No nursery has ever been found. No one has observed one giving birth, or mating, or forming any kind of group. They appear alone, silent giants in a black void. And when you consider how large they are, up to 18 feet in some cases, the implications are staggering. How can such a massive animal be so hidden? Where are they when we're not watching? What else lives with them? Some scientists believe the megamouth represents a relict lineage, a type of shark whose ancestors date back tens of millions of years. A survivor, not unlike the coelacanth, the living fossil fish once thought extinct since the time of the dinosaurs, only to be found alive and well in modern waters. In this light, the megamouth becomes something more than just a deep-sea anomaly. It becomes a messenger from a forgotten world, an echo of evolutionary history, one that moved silently through epochs, unchanged, until we found it by accident. But not everyone believes the story ends with biology. There are those, marine folklorists, fringe theorists, even a few biologists working on the edge of accepted science, who see the megamouth as a signpost, a clue. They point to the glow in its mouth. Why would a filter feeder need bioluminescence? Why would a shark, adapted for slow, energy-saving glides in the Black Ocean, need to glow at all? Some propose it's a lure, drawing in planktonic prey. Others suggest the glow is a signal, not to food, but to others of its kind, or to something older, something deeper. After all, the deep sea is not quiet. It pulses with sound, vibration, light invisible to human eyes. And in that dark, high-pressure realm, communication takes on different forms. Could the megamouth be part of a system we barely perceive? A participant in patterns beyond our understanding? We know that whales sing songs that span thousands of miles. We know that some deep-sea squid flash intricate light codes. We know that certain species of eel coordinate mass migrations using subtle cues we still haven't decoded. What if the megamouth is part of this unseen conversation? What if we're only seeing the edge of something vast? A biological network, stretching through the Hadal zones of the Pacific? Or something stranger? There are legends, whispered among island communities near the Philippines, Taiwan, and Indonesia, of great, slow-moving creatures that appear only at night. Not monsters, not demons, but watchers, silent witnesses to the deep, sometimes mistaken for ghost ships or moving shadows beneath fishing vessels. These shapes glide just below the surface and vanish when approached. And when a megamouth was first caught in the Philippines in 1998, elders in a coastal village reportedly said, "It is not meant to be touched." They returned the body to the sea, not from scientific caution, but from respect, from fear perhaps that this was not just an animal, but a sentinel. One of the rare times science and folklore seemed to whisper the same thing. We do not know what we've found, and maybe we're not meant to. In recent years, as submersibles and deep-sea drones have begun to penetrate deeper waters for longer durations, more megamouths have been filmed. Always solitary, always gliding. Some footage shows them swimming in loops, slow spirals, rising, falling, moving not toward food, but as if tracing something unseen. An ancient current, a field, a path. And the glowing patches in their mouths? They still baffle researchers. Unlike anglerfish or lanternfish, whose lures serve specific predatory purposes, the megamouth's bioluminescence seems diffused, soft, ambient. It doesn't flash or flicker. It glows steadily. Some believe it's a trick of adaptation. Others see design. And so, the mystery grows. This is no apex predator, no hunter of the abyss. This is something else entirely. A creature from another era, still drifting through ours. Living proof that the ocean hides more than teeth and speed. It hides subtlety. It hides intelligence of a kind we don't yet recognize. And perhaps, it hides things that aren't supposed to be seen. The megamouth shark is not terrifying like the great white, nor awe-inspiring like the whale shark. It is slow, strange, uncomfortable to look at. Its mouth is too big, its face too slack. It seems more alien than predatory, and maybe that's what makes it so important. It reminds us that we are still blind to most of what lives in the sea. That even now, with all our satellites and sensors, we know almost nothing about what happens below 1,000 feet. The megamouth is a reminder that monsters don't always look monstrous, that the abyss still has secrets, and that sometimes the ocean gives us a glimpse, only to take it away again. As of now, it has never been observed giving birth. Its young have never been found. Its mating behavior is unknown. It is not endangered, nor protected in most places, because we don't even know how many exist. It may be common in the depths and rare at the surface, or it may be dying out, one silent giant at a time. We simply don't know. But every time one appears, a flicker on a sonar screen, a silhouette near a deep-sea trench, a glimmer of light in a wide, waiting mouth. It reminds us, the ocean is still the largest unexplored wilderness on Earth, and in its depths swim creatures not yet named, not yet understood, and maybe never meant to be. The megamouth is not a legend, it is real, and that might be the strangest part of all. Story 2. The Demons of the Dark, Anglerfish and Fangtooths. From the strange silence of the megamouth shark, a creature so elusive we aren't even sure how it reproduces, we now descend deeper into the abyss, not in search of giants, but of nightmares. For while the ocean hides creatures of immense scale and mystery, it also breeds something far more unnerving. Predators born of total darkness. Creatures that have no need for sunlight, no use for beauty, and no intention of being seen. They are not large, they are not graceful, but in the ink-black trenches of the Pacific, they are death made efficient and monstrous. They do not just live in the deep, they rule it. These are the demons of the dark, the anglerfish, the fangtooth. Let's begin our descent. At 3,000 feet below the surface, sunlight vanishes entirely. The water becomes ink, thick, black, absolute. This is the beginning of the midnight zone, an eternal night where pressure crushes like stone and heat is a distant memory. The silence here is total, the cold, unrelenting. But life somehow thrives. Not in the way we know it, not in familiar shapes or vibrant schools, but in scattered, haunting forms, each a product of ruthless evolution. Hovering just above the seafloor, a shape begins to stir. It is not sleek like a dolphin or nimble like a squid. It is bulbous, hulking. Its skin is a matte black, barely distinguishable from the void around it. But what betrays its presence is a single glowing light, flickering like a lantern held in a shaking hand. This is the black sea devil, a species of anglerfish that haunts the deep Pacific. And that light is bait. Its real name is Melanocetus johnsoni, a predator built for one thing: ambush. Attached to the top of its head is a long rod-like filament called an elysium. At the tip of this appendage is the esker, a tiny globe of glowing bacteria, bioluminescent, pulsing, hypnotic. In the darkness of the trench, it's the only thing that moves. Small fish, shrimp, even other anglerfish, they're drawn to the glow, mistaking it for food, or light, or life. But as they approach, the sea devil's mouth unhinges. It does not bite, it swallows. The jaws open impossibly wide. The stomach stretches to accommodate prey nearly as large as the anglerfish itself. Teeth curve inward like thorns, not to shred, but to imprison. Once inside, nothing escapes. And when the ambush is done, the lantern goes dim, until the next. What's perhaps most haunting about the anglerfish is not its shape, not even its lure, but its love life. Because in this dark world, finding a mate is nearly impossible. There's no courtship, no dances, no songs, just scent and desperation. Male anglerfish are tiny, often no more than an inch long. Born with one purpose, to find a female. And when they do, they never leave. They bite her and fuse. Literally, their bodies merge, bloodstreams connect. The male loses his eyes, his fins, even his internal organs. He becomes a living appendage, a parasitic mate, forever attached. Some females carry up to 6 males fused to their body, small, shriveled shadows, kept alive only to fertilize eggs on demand. It is perhaps the most extreme reproductive strategy in the animal kingdom, and it is disturbingly common in the deep. In 2016, scientists using a submersible camera filmed the first ever footage of a mating pair of black sea devils. A female with a male fused to her underside, his body slowly atrophying. It was not beautiful, it was not romantic, but it was evolution, perfected for darkness. The anglerfish is not the only horror hiding in these depths. If the black sea devil is a ghostly hunter, then the fangtooth is a monster of the flesh. It does not glide or shimmer or pulse with light. It charges. Chanifrine and Anoplogaster cornuta are 2 of its names, but most simply call it the fangtooth. A small fish, rarely more than 6 inches long. But what it lacks in size, it makes up for in one singular, unforgettable feature: its teeth, the largest in the ocean, relative to body size. They do not fit in its mouth. They extend beyond it, needle-thin, dagger-long. So long, in fact, that the fangtooth has evolved special sockets in its skull just to sheath its fangs when it closes its mouth. They are not serrated. They do not need to be. These are weapons meant to pierce, pin, and trap. Like spears on a mousetrap, instant, fatal, final. Unlike the anglerfish, the fangtooth hunts actively. It swims with short, erratic bursts. Its body is thick, armored, and armored again. Eyes small, brain smaller. It does not strategize. It strikes. What makes it even more unsettling is where it sometimes goes. Unlike many deep-sea creatures, the fangtooth is capable of vertical migration. That means, at night, it ascends, toward the surface, toward us. Not often, not far, but enough to be caught by fishermen, occasionally, enough to end up in nets. And when they do, freshly hauled from the abyss, still twitching, the sight is unforgettable. Their black skin gleams like coal. The jaws hang open. The teeth do not dull with death. They are often tossed back. No commercial value, no culinary appeal, but the memory lingers. It's easy to see why early sailors feared sea monsters. Creatures with too many teeth, eyes that didn't reflect the sun, mouths that opened wider than physics should allow. Because these monsters are real. Not metaphors, not legends, real. There is something deeply disturbing about the biology of the deep ocean. It is not just the adaptations, it's the philosophy behind them, the logic of the abyss. Here, life is shaped not by abundance, but by absence. No light, no warmth, no certainty. And so, the creatures that survive here, thrive here, must do so with a different playbook. Grow large jaws, because prey is rare and must never be missed. Grow big teeth, because bites must count. Evolve light, not to see, but to lure. Shrink your body, expand your mouth. Remove everything that is not essential, even romance, even selfhood. Every calorie counts, every mistake fatal. It is a world where only the most grotesque survive. And the grotesque, in the language of the deep, is not ugly, it is efficient. We often think of the deep sea as lifeless, empty, but this is a misunderstanding. Life is there, just sparse, slow, and strange. The anglerfish and the fangtooth are not alone. They share their world with gulper eels, whose jaws balloon like parachutes, with giant isopods, deep-sea crustaceans that resemble armored lice the size of cats, with barrel-eye fish, whose heads are translucent domes revealing tubular, rotating eyes. Each one a testament to the creativity of evolution in the most hostile corner of Earth. And yet, even now, we've only scratched the surface. Most deep-sea species have never been seen alive. Many have never been seen at all. And every expedition that descends into the trenches brings back new shapes, new lights, new teeth. In 2020, researchers off the coast of Australia filmed a new species of anglerfish, unclassified, unstudied, hovering in the water like a floating nightmare, its lure flickering like a dying candle. It was there for only seconds, but in that moment, it reminded us, the monsters of the deep are not past tense. They are alive, watching, waiting, and perhaps hunting. Why do these creatures look the way they do? Why such disproportionate jaws, such impractical teeth? Why evolve light in a place that offers none? Science provides answers, but only in part. Bioluminescence is an adaptation, a way to attract prey, or mates, or confuse predators. The teeth, oversized and curved, are ideal for holding onto slippery fish in the pressure-heavy dark. The black skin, camouflage, total absorption of light, a body that cannot be seen, even if you're looking straight at it. But there is something deeper here, something harder to name. These creatures are not just alien, they are reminders of how far life will go to survive, of what evolution becomes when shaped by silence and pressure, and of how unfamiliar Earth itself can be. We often look to the stars for aliens, but sometimes all we need is a submersible, a camera, and a little light. In the darkness, the demons come, not to haunt, but to endure. The anglerfish, the fangtooth, neither is large, neither is famous, but both are symbols of the unknown. And in the deep sea, the unknown is vast. What else swims below, unseen? What teeth have we not yet discovered? What eyes have not yet turned toward our lights? The deeper we go, the stranger it gets. And the most terrifying creatures are the ones that don't need to be seen. Not all monsters are myths. Some are smaller than a loaf of bread, and some are real. Story 3. The Goblin of the Abyss. From the glowing lights and gaping jaws of the anglerfish and fangtooth, we descend further still, deeper into the ocean's belly, past the crushing weight and bitter cold. past even the flickers of bioluminescence. And here, in this forgotten realm, swims something that looks like it shouldn't exist. Something ancient, spectral, and utterly bizarre. It does not hunt with stealth. It does not glide with grace. It lingers, pale, sluggish, translucent, a phantom of flesh. And when it opens its mouth, or rather, when its jaw slingshots forward from its skull like some grotesque contraption, you realize why this creature has earned its name. They call it the Goblin Shark, a name that feels almost whimsical, if not for the reality of the beast. Because this is no fairy tale goblin. This is an apex relic, a monster not of myth, but of memory, a living fossil. Let us begin not with its discovery, but with its nature. For to understand the Goblin Shark is to understand a creature shaped not by time, but preserved by it. The Goblin Shark, Mitsukurina ostoni, is a deep-sea shark species so distinct, it is the sole surviving member of its family, Mitsukurinidae. All others are gone, fossilized, forgotten. But this one endures. It is a creature of twilight and pressure, typically found at depths between 100 and 1,200 meters. Though some have been recorded even deeper, the Goblin Shark makes its home along the outer continental shelves and upper slopes of the ocean floor, places where sunlight has long since died, and the world is dictated not by sight or speed, but by stillness. And in this stillness, evolution has shaped a body like no other. At first glance, it hardly resembles a shark. Gone is the torpedo shape, the muscular elegance of the great white, or mako. In its place is a long, flabby body with soft, pinkish skin that often appears translucent. You can see its blood vessels. Its flesh is pale and rubbery, almost gelatinous. It doesn't need to be firm. It doesn't need to be fast. In the deep, there is no chase, only the weight. Its fins are small, its tail long and thin, but it's the head that captures attention, and then, very quickly, unsettles it. The snout is elongated into a narrow, flattened blade, a protruding spike that looks almost like a weapon. It juts forward from the skull like the prow of some ancient ship. This snout is densely packed with sensory organs, electroreceptors called ampullae of Lorenzini. These allow the Goblin Shark to detect the faintest electrical signals in the water, a heartbeat, a twitch, a breath. Even buried prey can be sensed through this extrasensory blade. But that's only the beginning. What the Goblin Shark is truly known for is its jaw. In most sharks, the jaw is mobile, but still contained, hinged, predictable. But the Goblin Shark defies this convention. When it strikes, its jaws shoot forward in an almost mechanical burst, like a mousetrap uncoiling, like a nightmare blooming from within. In one of the most extreme examples of jaw protrusion in the animal kingdom, the Goblin Shark can launch its entire mouth forward nearly 10% of its body length. The jaws, filled with nail-like teeth, fire outward in a lightning-fast lunge, grabbing prey before snapping back into the head. It looks unnatural. Even animated footage struggles to capture the sheer alien movement of it. Biologists have described it as slingshot feeding, a term both accurate and unsettling. Imagine being a small fish, a squid, or a crustacean drifting silently in the gloom. You sense nothing, you hear nothing, and then, from the void, a pale shape stirs, and suddenly a mouth launches from its face and closes around you. There is no warning, no chase, just stillness, and then violence. The Goblin Shark feeds this way because it must. Its habitat is a realm of scarcity. Prey is few and far between. Energy must be conserved. And when the moment to strike finally comes, it must be absolute. Its teeth are narrow, needle-like, and numerous, perfect for grasping slippery prey. The upper and lower jaws contain multiple rows, and the teeth are not designed for cutting or tearing. They are for impaling, holding, swallowing whole. Its stomach contents, when studied, reveal a diet of teleost fishes, cephalopods, and crustaceans. Nothing large, nothing glamorous. But for a predator of the deep, efficiency matters more than elegance. The goblin shark's anatomy is a map of compromise. Its muscles are weak, its skin is soft. Its buoyancy is aided by a large, oily liver, a trait shared with many deep-sea sharks. It is not built for speed or agility. It is built to float, to drift, to wait. And it's in that waiting it becomes something eerie. When caught, rare though that is, the goblin shark often dies quickly. It is not made for the surface. The pressure difference damages it. Its coloration fades, and its body, once spectral and sleek in the deep, appears limp and awkward in the air. Perhaps that's why it feels so strange to behold, because it is not meant to be seen, like a ghost dragged from its grave. And yet, we have seen it. The first scientific encounter with the goblin shark came in 1898, off the coast of Japan. A specimen was captured near Yokohama and brought to the attention of American ichthyologist David Starr Jordan, who, alongside his colleague B.W. Everman, formally described the creature. They named it Mitsukurina austoni, honoring Professor Kakichi Mitsukuri of the University of Tokyo, and Alan Austin, a British naturalist and collector who supplied the specimen. Even in that first encounter, the goblin shark puzzled experts. It didn't fit cleanly into existing categories. Its skeletal features, jaw structure, and soft body suggested a lineage distinct from most modern sharks. And indeed, fossil records later confirmed this. Fossils of related goblin shark species date back over 125 million years, placing them in the early Cretaceous period. That's the age of dinosaurs. When the seas were ruled by massive marine reptiles and the land trembled under the weight of tyrannosaurs, the ancestors of the goblin shark were already there, and they have changed very little since. This is why the goblin shark is considered a living fossil. It has persisted through extinction events, climate shifts, continental drift. It has watched entire genera rise and fall, and yet it has remained almost untouched. Not because it is invincible, but because it found a niche so remote, so stable, and so unchallenged that it was never forced to change. That niche, however, has also kept it hidden. Most sightings of the goblin shark come not from observation, but from accident. Deep-sea trawlers sometimes bring them up in nets, especially off the coasts of Japan, Portugal, South Africa, and the Gulf of Mexico. In some cases, they are still alive when surfaced, though not for long. These encounters are so rare that for many decades, the goblin shark was considered near mythical among marine biologists. It didn't help that its appearance, when photographed, seemed more horror than biology. The elongated snout, the translucent skin, the grotesque jaw launch, all of it seemed more suited to fiction. Online, images and videos of goblin sharks have gone viral. Viewers call it an alien, a sea demon, a monster. And in a sense, they are right. But not because it is malevolent, because it is ancient, because it is real, because it is a mirror held to evolution's strangest corridors. The goblin shark has no known predators, but that doesn't mean it is safe. As deep-sea fishing expands and human activity pushes further into the abyss, the goblin shark's home becomes less isolated, more vulnerable. Noise pollution, trawling, and deep-sea mining all threaten to disrupt the delicate ecosystems of the deep. We do not yet know how many goblin sharks exist. We don't even fully understand their reproduction, gestation, or lifespan. But like so many deep-sea creatures, they are likely slow to mature and long-lived, traits that make them especially sensitive to environmental change. And so, the goblin shark teeters in a strange space. Not quite endangered, not quite secure. It floats, as it always has, in the grey space between known and unknown. Some believe there are larger specimens yet to be found. The ones captured to date have typically measured between 3 and 4 meters, though unverified reports suggest individuals over 5 meters long. Could there be giants drifting in the dark? Massive goblin sharks that have never surfaced, never been seen? It is not impossible. The ocean is vast. The Mariana Trench alone spans over 1,500 miles. In its folds and canyons, in the cold silences where light has never reached, the goblin shark may glide, watching, waiting. Perhaps that is why it unnerves us, because it is not aggressive, not beautiful, not deadly in the cinematic sense. It is wrong. Or rather, it is a reminder that evolution is not always elegant, that survival does not require symmetry or speed. That life, when pressed against the walls of darkness, will twist itself into whatever shape it must. And in the goblin shark, that shape is alien. Not because it comes from another world, but because it is from this one, a version of Earth we were never meant to see. So the next time you stare into the ocean, remember this. There are creatures down there that have not changed in 100 million years. Creatures that hunt with lightning jaws. Creatures that do not look like they belong, and yet they do, because the ocean keeps its secrets. And sometimes the strangest monsters are the ones that never went extinct. They simply sank and stayed there, waiting, watching, drifting in the dark. Story 4. The Serpent of the Deep. Some monsters do not roar or charge. They do not split the waves with giant limbs or shatter hulls with teeth. Some monsters do not even rise from the depths. They wait, lurking not in motion, but in form. They coil like memory, slow, silent, ancient, written not in the chaos of predation, but in the poetry of patience. The goblin shark reminds us that the strange often survives by staying hidden, but it is not alone. In the shadows behind it, something older still twists through the deep, something long and sinuous, with rows of trident-shaped teeth and a face that looks back at us like a warning from a forgotten age. It does not strike with brute force. It coils, and then it lunges. Let us now follow that coil, that ripple in the dark. Not a splash, but a whisper. A winding thread through the waters of the Pacific. Because not all monsters were made to be seen. Some were made to be remembered. It's time to meet the Serpent of the Deep. The sea has always had serpents. Long before sonar and steel, before satellites scanned the surface and cables crawled the seafloor, there were stories. Sailors spoke of writhing shapes beneath the waves, long, dark bodies that curled around masts or slithered past the hulls of fishing boats. Sometimes they described them with eyes the size of plates. Other times, the eyes were absent entirely, as if the thing that watched them had no need for sight, or, worse, had already seen too much. From the Norse Jörmungandr to the Greek Cetus, from the Maori Taniwa to Japan's Ikuchi, the image returns again and again across time and culture. The serpent of the sea. Long, ancient, and unknowable. But what if some of those stories weren't inventions? What if something real was glimpsed? Not often, not clearly, but just enough to stick in the mind. Just enough to twist a fisherman's tale into a legend. What if the myth had teeth? In 1884, off the coast of Japan, a curious creature was pulled from the water. It was long and dark, eel-like in shape, but unmistakably shark in feature. It had an odd, frilly collar around its neck, as if wearing gills like lace. And its mouth. Its mouth was filled with strange, backward-facing teeth, each shaped like a miniature trident, arranged in rows upon rows. It was the first recorded specimen of a creature we now call the frilled shark. But this wasn't a discovery in the traditional sense. It was more like a resurfacing, because this creature was not new, not by any measure. The frilled shark, Chlamydocelicus anguineus, is a species so old its fossil record dates back over 80 million years. It has survived epochs, climatic shifts, mass extinctions, the rise and fall of continents. And through it all, it has remained largely unchanged. It is often called a living fossil, but even that term feels inadequate. It is not simply living, it is lurking, a body built for stealth, not spectacle. An elongated frame, often over 6 feet in length, with a flexible, cartilaginous skeleton that lets it bend and twist with uncanny smoothness. It doesn't swim like other sharks, with stiff bursts of motion. Instead, it glides, undulating through the water like an eel or, yes, a serpent. Its coloration is muddy brown, often appearing dark grey or even black at depth. Camouflage for an environment without light. Its eyes are small, its fins reduced. It is not made to chase, it is made to wait. And when it strikes like a whip. But perhaps its most unsettling feature is its mouth. Unhinging upward instead of downward, the frilled shark's jaw can expand to engulf prey half its size. Its teeth, small, needle-like, and hooked, are arranged in over 20 rows, totaling more than 300. And unlike other sharks, which rely on sheer force to bite and rend, the frilled shark's teeth are designed not to kill instantly, but to hold, to trap. Once inside, prey cannot escape. Each attempt to wriggle free only drives it deeper. The shark doesn't need to chase again. It simply waits for the struggling to stop. And in the deep, everything stops eventually. Frilled sharks have been spotted in both the Atlantic and Pacific Oceans, usually at depths between 500 and 1,500 meters. But their range is uncertain. They appear rarely, and when they do, it is often by accident. Hauled up by deep-sea trawlers or found dying at the surface, their tissues ruptured by the change in pressure. Most people will never see one. And that may be part of the point. In Japan, the frilled shark is called ribbon unagi, the ribbon eel. It has also been mistaken for a sea serpent on more than one occasion. In 2007, a live specimen was found near the surface off the coast of Shizuoka. Footage of the creature, writhing and twisting in an aquarium tank, quickly went viral. Its face, with flared gills and lidless eyes, appeared almost alien. Its motion was hypnotic, as if it didn't belong to any familiar category of movement. Some viewers were awed, others disturbed. Many thought it couldn't possibly be real. But it was, and it still is, because the frilled shark is not extinct. It never went away. It simply stayed in the one place where time cannot find you. the bottom of the ocean, and the deeper you look, the stranger it gets. The frilled shark's anatomy suggests it is not optimized for fast motion or frequent feeding. Its liver, unusually large and filled with low-density oils, helps it remain neutrally buoyant, meaning it can hover in place with little effort. It likely ambushes prey, using its long coiling body to lunge forward in sudden bursts. In the pitch black of the bathyal zone, the so-called midnight zone of the ocean, movement is currency. Sound, light, vibration, every signal is a risk. So the frilled shark minimizes all of them. Its muscles are soft, its metabolism slow, its behavior reclusive. It is not built to dominate. It is built to endure. Scientists believe its diet consists mostly of squid, along with smaller fish and cephalopods. Bite marks on squid bodies found at depth seem to match the tooth pattern of the frilled shark. Neat, parallel slashes that align with its rows of barbed teeth. But the details remain elusive. The shark is rarely observed in the wild. Most of what we know comes from accidental captures or the dissection of expired specimens. Even its reproductive habits are mysterious. It is believed to be ovoviviparous, meaning the young develop in eggs inside the mother's body and are born live. But no full gestation cycle has ever been documented. Estimates suggest that pregnancies may last over 3 years. If true, it would be one of the longest known gestation periods of any vertebrate. Why? Because in the deep, survival is slow. Time doesn't move the way it does near the surface. Food is rare, energy is precious, and every adaptation must serve the cause of stillness, of silence, of waiting. So how did a creature so hidden become the poster child for sea serpent myths? Perhaps the answer lies not in the science, but in the silhouette. Imagine being a sailor in the 16th century, drifting across the North Atlantic, fog thick around the hull. Your instruments are primitive, your maps uncertain. And then, from the side of the ship, you glimpse something, a long body undulating just beneath the surface. A snake? No, it has gills, a head, a mouth. Then it dives again, vanishes. The mind, already steeped in tales of leviathans and krakens, fills in the rest. You've seen a serpent, and you weren't wrong, because for those few seconds, you saw the deep remembering, and the frilled shark is the memory. Throughout history, we've seen countless reports of sea serpents. The famous Gloucester sea serpent, sighted off the coast of Massachusetts in 1817. The Cadborosaurus of British Columbia. The mysterious beast reported by the crew of HMS Daedalus in 1848. Long bodies, coiling motion, undulating spines, sometimes horns, sometimes fins, often teeth. Could these have been frilled sharks? Perhaps not in every case. But it's not a stretch to imagine that rare surface appearances, especially of dying or disoriented specimens, may have birthed legends. Their movement is distinct, their shape uncanny, and their jaws. Their jaws would make anyone stare. But it's not just mistaken identity that makes the frilled shark so compelling. It's what it represents, a creature that shouldn't exist, and yet does. An echo of an older Earth, one before humans, before mammals, before even birds took flight. A time when the oceans were ruled by reptiles and giants, when every shadow could be teeth. The frilled shark is a ghost from that age, not a remnant, not a relic, a survivor. It is what happens when evolution does not forget, but instead whispers through time, shaping something not for glory, but for the long haul. There are theories, of course. Some believe there may be larger, unknown relatives of the frilled shark still lurking in uncharted depths. If this species could go so long undetected or misunderstood, could there be others? Similar in shape, but far greater in size? It's not impossible. New species of deep-sea shark are discovered regularly. Most are small, some are blind, others glow, but all share one trait. They surprise us, because the deep remains, by far, the least explored part of our planet. We've mapped more of Mars than we have of the ocean floor, and creatures like the frilled shark remind us why that matters. Because every so often, the deep lifts the veil. Not fully, not kindly, but just enough for us to glimpse something we forgot we feared. A shape that does not blink, a body that does not rest, and a mouth, ancient, serrated, unchanging, that still opens in the dark. There is no roar, no splash, only the slow rising coil, and then the strike, and then it is gone again. No fossils, no bones, no proof, only a ripple, only a story. And sometimes, that's all it takes. So the next time you hear tales of sea serpents, of writhing monsters with endless bodies and eyes like cold glass, remember this: there is a creature in the ocean that fits the description. It doesn't roar, it doesn't chase, it waits. And it has been waiting for 80 million years, in the dark, in the silence, just beneath us, because some monsters never needed to evolve. They were perfect from the beginning, and they've been gliding through the abyss ever since. Patient, timeless, unseen, but always there, waiting, watching, and drifting, still, in the deepest parts of the sea. Story 5. The deepest fish in the world. From the depths of the Mariana Trench, where the ocean's silence is broken only by the groans of tectonic plates and the occasional flicker of bioluminescent life, a new presence glides through the darkness, one that seems more ghost than fish. It has no scales, no bright colors, no sharp fangs or glowing lure to announce its existence. Instead, it drifts, translucent and gelatinous, through a realm of pressure and cold where most life cannot survive. At over 8,000 meters below the surface, where the weight of the water above would crush a human body in an instant, this unlikely creature thrives. It is known as the Mariana snailfish, and it holds a record no other fish has achieved, the deepest dwelling fish ever observed by humans. But to understand the mystery of the Mariana snailfish, how it survives, how it came to be, and what it represents, we must first understand the world it calls home. The Mariana Trench is not merely deep, it is profoundly alien. A scar in the Earth's crust stretching 1,500 miles long and over 36,000 feet deep at its lowest point. It forms the boundary between two massive tectonic plates. Here, in the trench's deepest pits, including the Challenger Deep, darkness is absolute. Temperatures hover near freezing, and the pressure is so intense that water behaves more like a heavy compressive blanket than the fluid we know on the surface. Life here is not just rare, it's extreme. For decades, scientists believed vertebrate life, life with backbones, couldn't survive in these conditions. Proteins would denature, cell membranes would collapse, and the simple act of being, of maintaining structure in such a crushing environment, would be chemically impossible. But that assumption changed in 2014, when a team of researchers using deep-diving landers, specially designed unmanned vehicles capable of withstanding incredible pressure, captured something on camera. At a depth of 8,145 meters, drifting slowly past the lens, was a pale, fluttering form. It didn't swim like a typical fish. It hovered, undulating softly, its wing-like fins gently fanning against the water. Its body was almost see-through, its head rounded, with tiny black eyes barely visible against its ghostly skin. This was Pseudoliparis swirei, the Mariana snailfish. It moved with a serenity that belied the brutal world around it. There were no large predators at that depth, no rivals, no competitors. In this immense pressure cooker, it reigned alone, not through violence, but simply by being the only one capable of existing there. The discovery was a revelation. For years, the limit of fish habitation was thought to be around 8,200 meters. Beyond that, the density of the water and the pressure would prevent enzymes and cellular structures from functioning. But the Mariana snailfish had adapted. Its cells contained special proteins called osmolytes, which help stabilize other proteins under extreme conditions. Its bones, unlike those of most vertebrates, were extremely soft and flexible, reducing the risk of collapse. And its body, gelatinous and nearly formless, helped it resist the crushing force of the trench. It was not armored, it was not fast, but it was alive, far deeper than any fish should be. Its presence sparked a cascade of questions. If a vertebrate could live here, what else might be down there? What adaptations had allowed it to evolve in such a brutal world? And how long had it been living, unseen, at the bottom of the sea? Some scientists began to speculate that the Mariana snailfish wasn't alone. In 2017, researchers using deep-sea baited cameras in the trench reported sightings of what appeared to be an even deeper dwelling relative. Similar in shape and behavior, but paler, almost glowing, and even more delicate. This second snailfish, caught on video at depths just beyond 8,178 meters, has yet to be officially described or named. It has become a ghost among ghosts. What's striking about the Mariana snailfish is not only where it lives, but how. Unlike many deep-sea creatures that rely on detritus or microbial mats for food, the snailfish appears to be a predator. It feeds on amphipods, small shrimp-like crustaceans that are surprisingly abundant in the trench. These amphipods, in turn, consume the organic matter that sinks from the upper ocean. The constant rain of dead plankton, fish, and marine snow that filters down through the water column. The Mariana snailfish occupies a niche where no other vertebrate can compete. It is adapted not for speed or strength, but for endurance, for chemical resilience, for soft-bodied survival in a world without light, heat, or mercy. And this strange adaptation comes at a price. When specimens have been brought to the surface, a rare and difficult feat due to the pressure difference, they disintegrate quickly. Their bodies, so suited to the crushing depths, cannot withstand the lightness of our world. They collapse into jelly. Their bones become soup. Their very essence, fragile and ephemeral, is a thing that belongs only to the deep. It is, in every sense, a creature of another world. And yet, it is real. It raises haunting questions about evolution, about just how far life is willing to go, not just in distance, but in design. Most deep-sea fish evolved to tolerate increasing pressure by degrees. But the snailfish appears to have bypassed that curve, adapting in such a way that it thrives only at the bottom. It is not a visitor to the abyss. It is its native son. What's more, it does not appear monstrous. Unlike the anglerfish with its glowing lure, or the fangtooth with its oversized teeth, The Mariana snailfish seems almost peaceful. Its face is rounded. Its body lacks the harsh spines and jagged jaws common in the deep. It looks less like a predator and more like a memory, as if sculpted from glass and dream. And perhaps that's why it resonates so deeply with us. Because the Mariana snailfish is not a terror of the deep. It is a whisper, a reminder that life does not always fight the darkness. Sometimes it becomes part of it, melts into it, learns to move with the crushing weight instead of against it. In this way, the snailfish is not just a biological anomaly, it's a philosophical one. It challenges our ideas of what it means to be alive, not merely to survive, but to flourish in the most inhospitable conditions on Earth. And it reminds us that the ocean is still a frontier, not just in geography, but in thought. For all our satellites, submarines, and sonar, we still know so little about the deepest parts of our own planet. We know the names of Martian craters and the weather on Jupiter, but we don't know how many snailfish live in the Mariana Trench, or if something even stranger lies deeper still. We don't know what waits below 8,200 meters, what lives beyond even the snailfish's dominion. Some researchers have suggested that 8,200 meters may be close to the physiological limit for vertebrate life, the point at which pressure overcomes every adaptation. And yet, that limit has already been broken, twice. And in the silence of the trench, there may be more waiting, more fragile hunters drifting through the darkness, more translucent forms etched in water and patience. A few years after the discovery of Pseudoliparis swirei, researchers deployed autonomous landers deeper into the trench. They captured brief glimpses, blurred footage, and faint silhouettes of other soft-bodied fish, even more ephemeral than the snailfish. These sightings remain unconfirmed, unclassified, unnamed, but their shapes linger, and in the absence of certainty, wonder begins. Could there be an entire ecosystem at these depths? A network of creatures living in perpetual darkness, feeding on the sparse rains from above and the bodies of their neighbors? Could there be predators of the snailfish, or scavengers that dissolve bones even softer than jelly? And what if, deeper still, something watches them all? The Mariana snailfish may be the deepest fish ever recorded, but it may not be the deepest creature. Life, as it has proven time and again, is adaptable in ways we cannot predict. What looks like the end of one world may be the beginning of another. We imagine the deep as empty, but emptiness can be deceiving. The abyss does not roar, it does not flash, it waits. And in its stillness, in its silence, it shelters things we are only just beginning to understand. Soft things, ghostly things, things with no names. The Mariana snailfish is not a monster, it is a pioneer. And its presence tells us that even here, in the darkest, coldest, most crushing corners of the earth, life still finds a way to endure. Not with teeth, not with rage, but with quiet, with softness, with a patience shaped by pressure. It glides, unseen, through the waters we will never touch. It does not chase, it does not flee, it drifts, and in doing so, it reminds us of the most haunting truth of all. There are worlds beneath us, silent, invisible, enduring, where life is not a spark, but a whisper. And in the Mariana Trench, that whisper takes the shape of a fish with no scales, no color, no name until recently, but a fish that has lived longer in the abyss than we've known how to look. And who else might be there still, waiting? Story 6. the alien lights in the abyss. From the darkness of the trench floor, where snailfish drift like quiet phantoms, translucent and patient, we rise only slightly in depth, but into an entirely different realm of wonder. Because not all life in the abyss survives by hiding. Some announce their presence with light, soft pulses, flickering signals, brilliant, sudden flares. Down here, in the crushing blackness of the Mariana Trench, there are creatures that glow, and their light, cold, alien, hypnotic, is not reflected from above. It is made from within. This is the realm of bioluminescence, a domain of living lights. And of all the mysteries that dance in the deep, few are more ethereal than the ones that shine. In 2016, a remotely operated vehicle deployed by NOAA drifted silently through the trench's twilight depths, around 3,700 meters below the surface, its cameras scanning the ocean's hushed interior. The vehicle's floodlights moved slowly across the emptiness, casting beams through suspended particles of marine snow. The water was still, but alive with drifting specks, flakes of organic detritus that fall endlessly from above, like a soft rain of dust and death. Then something appeared in the frame, floating, motionless. At first, it resembled a paper lantern, spherical, translucent, and too symmetrical to be accidental. Its bell pulsed softly, expanding and contracting in perfect rhythm. But what drew immediate attention wasn't its motion. It was its glow. Inside, its bell were two arcs of light, one golden yellow, the other deep red. They ran like veins, branching and looping in mirrored symmetry, as if lit from within by twin circuits. There was no sound, of course, only the visual impression, captured in high-definition silence, of a being that seemed designed by someone or something not from here. The footage was released publicly and quickly went viral in scientific circles and beyond. Viewers around the world watched, transfixed, as the jelly hovered in place, not swimming, not retreating, just existing, suspended in the black. It was unlike any jellyfish formerly classified. And while experts later suggested it might belong to the genus Crossota, a group of deep-sea hydrozoans, no species name was attached. It remained undescribed, a ghost in the registry of life. And so the mystery jellyfish of the Mariana Trench became something more than just a new species. It became a question. How many other glowing creatures are down there, waiting just beyond the reach of light? How many remain unseen? Because they move in ways our machines do not, because they pulse in wavelengths our sensors can't detect. The deep sea, after all, is not just dark. It is lightless in a way that we, as surface creatures, can scarcely comprehend. No sun penetrates beyond a few hundred meters. And here, miles down, it is not night, it is absence. And yet, this is where light is born, not from the sun, not from fire, but from chemistry, from evolution, from survival. Bioluminescence is the result of a chemical reaction, typically involving the enzyme luciferase, acting on a molecule called luciferin, often in the presence of oxygen and other compounds. The outcome is light, cold, efficient, and silent. It's used for many purposes: to lure prey, to attract mates, to scare off predators, to communicate, or to confuse. But what's most haunting is the way it looks. Because deep-sea bioluminescence doesn't resemble anything on land. It doesn't flicker like flame. It doesn't glow like incandescent bulbs. It pulses, it flows. It coils and radiates and vanishes in flashes, like a thought escaping a dream. And while the mystery jellyfish from 2016 captured the public's imagination, it is far from alone. Somewhere in the trench, there drifts a fish known as the ghostfish, a relative of the snailfish, but even stranger. Its body is gelatinous and translucent. Its skin contains almost no pigment. Its muscles are barely defined because down here, strength is less important than neutrality. The ghostfish floats, hangs, watches. It too has been filmed. Once. In 2016, during the same expedition that recorded the glowing jelly, NOAA's Deep Discoverer ROV encountered the ghostfish for just a few moments. It hovered above the trench floor, finning gently, its head slightly bowed. Its eyes, small and pale, did not reflect light, because they weren't made to see light. The body of the ghostfish is so soft, it can deform under pressure without damage. Its internal organs are suspended in a semi-liquid matrix. There is no swim bladder, because such a gas-filled organ would collapse under the pressure. Instead, it moves by controlling the density of its tissues. And even that movement is slow, deliberate. It is a creature built not to resist the trench, but to belong to it. The ghostfish does not produce light, but in some ways, that makes its presence even more eerie. Because in a world of glowing predators and blinking prey, it is the absence of light that becomes strange. Many of the glowing species observed in the trench aren't fish at all. They are comb jellies, siphonophores, pelagic tunicates, creatures that defy classification in the minds of most surface dwellers. Some drift like tapestries, others stretch like wires, extending tendrils meters long. Some glow blue, others green. Some flash like strobe lights. Others emit a continuous, steady light, like beacons waiting for something to answer. One species of comb jelly found near the Mariana Trench produces light not just as a glow, but as a rainbow, a refraction effect caused by the movement of cilia on its body. These cilia, beating in unison, create waves of color that ripple along its length, a living shimmer in the darkness. Another, a siphonophore, a colonial organism made of multiple specialized units, produces flashes of light at intervals, each pulse running along its body like a signal or a warning. The question is, for whom? Because many of the creatures observed in the trench, including these bioluminescent jellies, exist in such extreme conditions that very few known predators could reach them. And yet, they flash, they glow, they communicate. Are they talking to each other, to rivals, or to someone or something that we have yet to see? In 2015, researchers recorded a vertical curtain of light captured by deep-sea cameras off the trench's slope. The source was never found. It lasted only seconds, but its regularity and symmetry suggested a structured emission, not random, not passive, as if something chose to release that light. Some fringe theorists have proposed that bioluminescence at such depths could serve as a kind of long-distance language, an optical Morse code used by trench dwellers to signal across vast distances. We have no proof, but we do have patterns. Many of these organisms display rhythm, regular intervals, geometric distributions of glowing points. Some pulse in Fibonacci ratios, others in sequences that repeat every 3.14 seconds, almost too coincidentally. Coincidence or cognition? Science holds firm to its tools, but those tools falter when they reach the limits of observation. After all, we've explored less than 5% of the ocean, and the trench, the deepest, least accessible region, remains a shadow within a shadow. Every ROV sent down has a limited field of view, a limited battery, a limited time. What lives beyond that cone of artificial light? We know that deep-sea squid, some over 6 meters long, use bioluminescent patterns not only to blend in with downwelling light from the surface, but to mimic other species entirely. Some flash decoy signals to confuse predators. Some create trails of glowing dots behind them, drawing attackers away while the squid itself disappears into shadow. But others pulse in slow, rising intensities, as if calling, as if beckoning. One species of dragonfish found near the trench's upper rim possesses a unique feature, a light-producing barbel that it dangles like a lure. But unlike surface anglerfish, this light is capable of shifting wavelengths. That's rare, because most bioluminescence in the ocean is blue or green, wavelengths that travel farthest underwater. But this dragonfish can emit red, a wavelength most deep-sea creatures can't even see, meaning it can signal in secret. To whom? We don't know. The red glow cuts through the dark, seen only by those who have evolved the rare ability to perceive it. Perhaps mates, perhaps allies, perhaps something else. Even stranger are the reports, rare, unconfirmed, but persistent, of coordinated displays. Walls of glowing organisms drifting in formation. Spiral patterns rising from the seafloor. Sudden synchronized flashes seen by passing ROVs that vanish the moment the light swings toward them. In 2019, one such report described a cluster of lights moving against the current, maintaining a perfect triangle as they ascended, then scattered. The ROV lost track of them, but the footage remains. It hasn't been released to the public, at least not in full. What has been published are fragments, blurry frames of motion, light trails, and the unmistakable curve of something massive just outside the range of focus. Some scientists believe it was a school of bioluminescent squid. Others suspect camera error. But a few, quietly, off record, admit something else. We don't know what we saw. And in the Mariana Trench, that's becoming a familiar refrain. Because for every species we capture, for every strange light we record, there are dozens, maybe hundreds, that vanish before we can name them. And many will never be seen again. Because bioluminescence is not just a tool for visibility, it is also a tool for concealment. Some deep-sea fish emit light from their bellies to match the dim glow of the water above, effectively erasing their shadows from predators below. Others produce light that mimics the surrounding marine snow, flickering just enough to vanish into the background noise. In a world without light, brightness becomes camouflage, and so the trench becomes not just a place of glowing creatures, but of creatures that use light to disappear. The idea that there could be species, entire populations, living in the trench that we have never seen, simply because they are too good at hiding, is not fantasy. It is scientific consensus. And when these unseen beings do appear, it is often by accident. A rogue current, a passing ROV, a flicker captured in a single frame of video. There is footage, rarely shared, of a jellyfish with 12 arms, each lined with luminous nodules, spiraling like a helix. It was seen only once. Near the slope of the trench wall, it hovered, then retreated, not by pulsing, but by folding in on itself, its arms spiraling inward until it simply vanished. No jet propulsion, no visible exit, just gone. Was it a real animal or a trick of light? The team that recorded the footage won't say. Not publicly, because in the deep, belief becomes a liability. Data is king. But in the silence after the dive, there are always whispers, And sometimes those whispers speak of shapes that move with purpose, of lights that don't just drift, but wait. One ROV pilot, experienced, veteran, rational, once described seeing a field of lights arrayed in a perfect circle on the seafloor. Not an arc, not a cluster, a circle, symmetrical, evenly spaced. He said they looked like landing beacons or sentries. They stayed in place for 4 minutes, then winked out one by one, counterclockwise. There was no further contact. The footage was recorded, but the official report lists it as a malfunction, and perhaps it was. In the trench, light bends, pressure distorts, electronics fail, but patterns rarely lie. And when we speak of patterns in the deep, we speak not of fantasy, but of form. Because biology, after all, is just pattern obeyed. And the patterns we've begun to glimpse in bioluminescent behavior, in rhythmic emissions, in formations too orderly to dismiss, suggest a structure we do not yet understand, perhaps one we were never meant to see. Some researchers now propose that deep-sea bioluminescence should be studied not just as a biological phenomenon, but as a system of language, a code. After all, humans once looked at fireflies and saw only blinking insects. It wasn't until centuries later that we realized their flashes carried meaning, species, gender, even mood. What then are we missing in the trench? What stories are being told in pulses and waves, unseen by human eyes? What warnings? What invitations? What memories? In the Mariana Trench, light is more than survival. It is conversation. It is camouflage. It is presence. In a world that erases all but the silent. The glowing jellyfish with yellow and red canals has not been seen again. But its image persists. A lantern in the abyss. A shape too symmetrical to ignore. Too foreign to explain. Some say it was just another jellyfish. Some say it was the start of something more. A new lineage, a signal, a sentinel. We may never know, because for every question we answer about the deep, another one lights up just out of reach. Flickering, calling, waiting. Story 7. The shrimp of unusual size. The deep has never been still. The glowing jellyfish, that delicate satellite of light and symmetry, may have faded from view, but something else has emerged from the shadows. No light, no bioluminescent signal, no elegant pulsation, just legs, too many of them, and a body that shouldn't be that size, not at that depth, because in the darkness of the Mariana Trench, not all monsters shimmer, some scuttle. Let's descend now into one of the deepest ambushes ever witnessed by science, a slow-moving, claw-clicking, jointed anomaly. Welcome to the world of the supergiant amphipods. They are real, and they are waiting. At first glance, there's nothing extraordinary about an amphipod. To most people, they're invisible. Tiny, shrimp-like crustaceans that dwell in the oceans, lakes, even freshwater creeks. In shallow waters, they rarely grow longer than a fingernail. And yet, in the Mariana Trench, that same form stretches to nearly a foot in length, sometimes more. It's a phenomenon called deep-sea gigantism, and it has created something truly monstrous. They are known simply, and appropriately, as supergiant amphipods. Their pale, segmented bodies resemble something prehistoric. Their legs are long and thin, giving them a strange, spidery gait. Their heads droop low, antennae writhing with slow purpose. And unlike their tiny cousins near the surface, these behemoths command attention. In 2012, when scientists lowered baited traps nearly 7,000 meters into the Kermadec Trench, a deep scar in the Pacific, not far from the Marianas, they were expecting to capture small amphipods. They weren't prepared for what the trap hauled up. There were the usual suspects, millimeter-long creatures drifting through the mesh like ghosts. But buried among them was something different, thicker, heavier, a specimen stretching over 28 centimeters long, nearly 30 times the size of a typical amphipod. They stared at it in disbelief. At that depth, such growth was thought improbable, even impossible. And yet, there it was, still wriggling, alive. It looked more alien than crustacean, as though it had been sculpted for some ancient seafloor, or designed by a mind unfamiliar with surface biology. The team didn't find just one. There were multiple. A whole cluster of them had converged on the trap, swarming the bait like phantoms. Most were over 20 centimeters long. Some had pale, translucent shells that shimmered under light. Others were more opaque, like bone under cloudy ice. Their legs clicked softly when handled. Their eyes, small and dark, didn't seem to move, but their bodies did. They were fast, too fast. And then, just as quickly as they had appeared, they were gone. In the years that followed, the specimens were preserved, photographed, and analyzed. For a time, they became a kind of deep-sea celebrity, passed from laboratory to laboratory, filmed for documentaries, displayed behind glass. But it wasn't until 2014 that researchers got their first glimpse of them alive, in the wild. Using a free-falling baited camera system, marine biologists descended into the depths of the Mariana Trench, lowering sensors and high-resolution cameras to around 7,500 meters. The trench itself is a different world, a realm of near-constant pressure and unimaginable cold. When the footage was reviewed, the researchers expected the usual: slow drifts of sediment, the occasional flicker of a snailfish, the eerie silence of the deep. But then, motion. From the right of the screen, something crawled into view. Long-legged, pale-bodied, an amphipod, but not like the ones they'd studied on shore. This one moved with purpose, not drifting, not floating. It walked. Its legs moved in sync, not randomly, but with deliberate coordination. A second followed, then a third. They swarmed the bait cage like ghosts with skeleton limbs. It was the first time these creatures had ever been captured on video in their natural habitat. They didn't glow, they didn't pulse, they didn't shimmer. But there was something deeply unsettling about their presence, like relics or invaders, too large for their environment, too confident in their movement, and most importantly, too unknown. So, how do these creatures grow so large? How does a shrimp-like animal become nearly a foot long, in a place where food is scarce and energy precious? The answer is layered and not entirely agreed upon. Some scientists point to deep-sea gigantism, a trend observed in many abyssal species. The idea is that colder temperatures, higher pressure, and slower metabolisms allow deep-sea organisms to grow larger than their shallow water counterparts. In the absence of predators, they don't need to stay small and agile. And in the cold, every process slows. Cell division, growth rates, aging. These amphipods may take years, even decades, to reach full size. But the size grants advantages. They can travel farther between meals. They can dominate bait sources. And in a place where calories are few and competition is fierce, that dominance matters. Another factor may be oxygen. Some regions of the deep ocean, including parts of the Mariana Trench, contain higher than expected oxygen levels. This oxygen may support larger body sizes, allowing for more robust respiratory systems and muscle development. Still, the phenomenon is not fully understood. Other trench-dwelling species do not show the same growth. Why these amphipods, and only these, become giants remains an open question. Their biology is a study in adaptation. Despite their size, they maintain many of the same anatomical features as smaller amphipods. Their exoskeleton is thin but surprisingly strong, flexible enough to survive pressure over 1,000 times that of the surface. Their limbs are highly articulated, designed for scavenging, and their gut contains enzymes capable of digesting rotting flesh, bone, and detritus. In essence, they are vacuum cleaners of the abyss. But some researchers suspect they're more than just scavengers. There are theories, unproven but plausible, that supergiant amphipods may prey on smaller invertebrates. Their movement suggests a degree of predatory behavior, and their presence at bait sites implies acute sensory detection, likely chemical or olfactory. They may detect food trails in the water and follow them for miles. In an environment of perpetual scarcity, this makes them formidable. They don't just wait for food, they go find it. The strangeness doesn't stop at their size or behavior. Their very existence raises evolutionary questions. Where did they come from? Are they a distinct species? Or simply an extreme variant of known amphipods? The answer is complicated. Genetic sequencing suggests that supergiant amphipods are closely related to known species, particularly Alicella gigantea, first discovered in the 1980s. But the Mariana specimens show enough morphological difference to suggest they may represent an entirely new clade, a unique branch of the crustacean family tree. They may have diverged millions of years ago, evolving slowly, in isolation, perfecting their bodies for the slow-motion chaos of the trench floor. There are also questions of range. Are these creatures unique to the Marianas and nearby trenches? Or do they haunt the floors of every deep basin, hiding in the crevices of the world? Sampling has been sparse. Every time a new trench is probed, different amphipods are found, some small, some large. But only a handful have reached the true supergiant classification. Whatever conditions created them are rare, but not impossible. In the folklore of surface dwellers, size often equates to menace. The Kraken, the Leviathan, the sea serpent. Gigantism implies power, but the amphipods challenge that notion. For all their size, they are not monsters. They do not attack. They do not stalk. They are recyclers, cleaners, silent contributors to the deep-sea food web. They devour what sinks, and in doing so, they keep the system moving. Without them, the trench might become a graveyard. Instead, it is a living corridor. Slow, quiet, efficient. But their appearance unsettles us nonetheless, because they remind us of scale, of transformation, that even something small, something unassuming, can, given time and the right pressure, become something else entirely. Something unrecognizable, something enduring. And then there is the mystery. Because for all our theories, the supergiant amphipod remains in many ways an enigma. Why are they so rare? Why so large? Why here and not everywhere? And most hauntingly, what else is growing in the dark? If a shrimp can become a monster, what might a squid become? Or a worm? Or something we haven't found yet? The deep changes everything. It doesn't just hide the unknown. It builds it, presses it into new forms, shapes it into legends, and occasionally it lets us see, but only briefly. The supergiant amphipods returned to the shadows, and in the years since, sightings have been scarce. We know they are down there, but they do not always come. Only sometimes, when the pressure is right, when the silence is thickest, when the abyss opens its hand and shows us what waits inside. Let's linger on that image of long legs crawling across the seafloor, of pale bodies feasting in silence, of creatures that shouldn't exist, but do. Not because of myths, but because of evidence, because of footage, because someone finally looked deep enough. The Mariana Trench gives us few gifts, but when it does, they are strange. They are quiet. They do not scream or roar or flash with light. They simply appear, as if they've always been there, because perhaps they have, and perhaps they are not alone, because in the cold beneath the world, there are always more things, more legs, more mouths, more time, waiting. But not all waiting things are still. Some move, some click, some crawl, and some never stop growing, even when no one is watching, especially when no one is watching. The deep sea doesn't forget. It remembers every meal, every silence, every trap, and once in a while, it sends something back. Large, lurking, legged, not mythical, not imagined, just overlooked, just underwater, just too big, and still growing. Story 8. The armoured pillbugs of the deep, the trench's giant isopods. From the long-limbed shadows of the amphipods, where the sea's forgotten insects loom in oversized silence, we now shift our gaze to something broader, lower, heavier, not quick, like the darting shrimp-like phantoms from before, but slower, deliberate, a kind of creeping weight that seems to press outward from the dark. Not a hunter, not a chaser, but a thing that waits and endures. A relic of the seabed itself, part armor, part scavenger, massive, segmented, and disturbingly still, until it moves. These are the armored pillbugs of the deep, giant isopods, ancient crustaceans that roam the abyssal plain like roaming beetles from some prehistoric nightmare. They do not shimmer or glow like their bioluminescent cousins. They do not flash across the trench walls like whispers of alien light. Instead, they crawl, mouths pressed close to mud, legs like mechanical fingers, and though they carry no teeth or venom, they feed. When the bones fall from above, when a whale carcass sinks silently into the deep, these are the ones that arrive, not in a frenzy, but in procession. Let us descend again, deeper now, into the gloom and sediment, and meet the isopods. It begins in the inky stillness of the bathypelagic zone, around 1,000 meters below the surface, though some of these creatures have been found even deeper, brushing the slopes of the Mariana Trench at 2,000 meters and beyond. Here, in a realm of eternal darkness and near freezing temperatures, life takes on forms both grotesque and ingenious. In this cold, crushing world, survival doesn't mean speed. It means armor. It means patience. It means being ready for the rarest of feasts. And the giant isopod, Bathynomus giganteus, is a master of that kind of waiting. At first glance, it resembles something strangely familiar, like a common pillbug, the kind found in gardens and basements across the world. But then, the scale shatters that comparison. A typical pillbug fits on a fingertip. This one could fill your lap. Some have been found measuring up to 2.5 feet long, roughly the size of a small dog, with a hard, segmented shell reminiscent of medieval plate armor and a dozen or more spindly legs that undulate in slow, rhythmic waves beneath its body. The giant isopod isn't built for beauty or elegance. It's built for pressure, for time, for the eternal cold. Its exoskeleton is ridged and pale, often an eerie lavender grey that catches light like bone. Its eyes, large, bulging, compound, reflect faint glimmers from submersibles, gleaming like clusters of glass beads embedded in a stone mask. But its face is its most unsettling feature, not because it's expressive, but because it isn't. It doesn't leer or scowl or smile. It simply watches, or more accurately, it absorbs. Giant isopods are scavengers, opportunists, cleaners of the abyss. They spend most of their time gliding slowly over the seabed, searching for anything organic, bits of decaying fish, fragments of squid, and when luck strikes, the remains of a fallen whale or shark. These events are rare, but when they happen, the isopods gather. Not in packs, not in cooperation, but as rivals drawn to the same feast. Once there, they don't nibble or pick delicately. They gorge. Their mouth parts, hidden beneath their hard shield-like heads, open to reveal a set of jagged, crushing appendages designed to break down even the toughest tissues. Cartilage, scales, even bone fragments. And they don't stop. Giant isopods have been observed feeding until they can barely move. Their bodies distended like overfilled bags, bulging grotesquely with whatever they've consumed. Some have been found still digesting a meal over a month after first feeding. This isn't gluttony, it's strategy. In the deep sea, food is scarce. In some areas of the Mariana slope, meals may arrive only a few times a year, or less. So when something edible appears, the only rule is eat everything, because the ocean won't feed you again for a long time. But as grotesque as this may seem, it's also efficient. Every inch of the isopod is designed to reduce effort. Its legs aren't built for speed. They're designed for crawling over uneven terrain without expending energy. Its antennae sweep slowly in front of it, detecting chemical cues in the water that might signal rotting flesh. Its metabolism is extraordinarily low, a reflection of its environment, where survival hinges not on quick bursts of action, but on enduring long droughts of silence and emptiness. And when it does find a meal, it becomes a living vault, stuffed, sealed, unmoving, just waiting to digest in darkness. But the mystery of the giant isopod doesn't lie only in its behavior. It lies in its lineage. Isopods are ancient. Fossil records suggest their ancestors have been crawling across the seafloor for over 300 million years, long before the first dinosaurs roamed the Earth. Back then, the world looked very different. Shallow seas covered much of the continents. Massive arthropods, including trilobites and eurypterids, prowled the oceans, filling niches that mammals wouldn't touch for another 250 million years. And deep beneath them, the early isopods were already perfecting their form, a body plan that has remained almost unchanged to this day. This makes them not only survivors, but witnesses. The giant isopod is a living fossil, one of the last remnants of a time when armor and patience ruled the sea. And yet, for something so ancient, it was barely known to science until recently. The first giant isopod wasn't formally described until the late 19th century, and even then, it was regarded as an oddity, collected from the Gulf of Mexico and later stored in a Paris museum. It wasn't until the age of deep-sea submersibles and robotic crawlers that researchers truly began to see just how widespread these creatures are. And the more we observed, the stranger the story became. Because while Bathynomus giganteus is the most famous of the group, it isn't alone. There are over 20 known species of giant isopod, each adapted to a slightly different depth, location, or feeding behavior. Some are smaller, staying under 10 inches in length. Others rival the largest crustaceans in size and strength, and new ones are still being discovered. In 2022, researchers examining the waters near Taiwan uncovered what they believed to be a new species, Bathynomus yucatanensis, a pale, spiny isopod nearly indistinguishable from its cousins, but with subtle differences in spine placement and body width. These aren't evolutionary leaps, they're evolutionary echoes, small, strange signals from the deep, reminders that even the most stable creatures are still adapting, still watching, still waiting. But it's not just their biology that unsettles us, it's the aesthetic. There is something inherently unnerving about the giant isopod, something that triggers the same reaction as ancient masks or insect swarms. It's not dangerous, it doesn't attack, and yet it feels wrong. Like something too old, too still, too unchanged. The deep sea does this often, presenting us with forms that don't fit our expectations of life. Creatures that blur the line between animal and artifact. And the giant isopod sits at the center of that blur. Part insect, part crustacean, part machine. It looks less like something that should exist, and more like something we should have built or found, rusting, buried in the silt. And then there's the question no one quite knows how to answer. Why so big? Giant isopods are one of many examples of a phenomenon known as deep-sea gigantism, the tendency for certain species to grow to enormous sizes in the deep ocean. We see it in amphipods, in squids, in worms. But the causes remain elusive. Some scientists believe it's a result of colder temperatures slowing metabolism and allowing for longer growth periods. Others suggest that larger sizes offer better energy efficiency, allowing creatures to store more resources during long food shortages. There's also the possibility that reduced predation plays a role. In the crushing depths, fewer threats may allow for more extravagant sizes. But whatever the cause, the result is always the same. Creatures that look like smaller species we know, but scaled to unsettling proportions. They appear familiar, and yet they aren't. They're not monsters, they're reminders of scale, of silence, of how little we know, and perhaps of what else might be waiting. Because while the giant isopod may seem like an isolated oddity, it's not alone. Across the trench floor, in the same dim silence, similar forms crawl. Some have never been caught, never been catalogued, only glimpsed in passing on a grainy submersible feed, their outlines skimming the edge of the light before disappearing back into black. Others have turned up in fishing trawls, pulled unexpectedly from the depths, curled tightly into armored spheres like ancient coins. There's even speculation that some of the more unusual trench noises, low-frequency scrapes, irregular pulses, may be caused by these bottom dwellers shifting rocks, digging, or colliding in ways we don't yet understand. Could entire colonies of massive isopods inhabit parts of the trench no human eye has ever seen? Could some grow even larger, beyond the 2-foot standard we know, in places where food is rarer and growth never truly ends? There's no evidence, but there's also no denial. Because down here, on the floor of the world, evidence is slow. The sea keeps its secrets sealed, behind pressure, behind time, behind distance. And the isopod? It doesn't seek our attention. It doesn't flash or signal or announce its presence. It simply continues, unchanged. Each armored plate another layer of time. Each meal another silence broken. Each step another click in the dark. We tend to focus our fears on teeth, on speed, on predators. But the isopod reminds us of another kind of fear, a quieter one. The fear of what waits, the fear of what watches, the fear of what remembers. And in the end, that may be the truest form of terror the deep can offer. Not what leaps, but what crawls, not what seeks, but what is always there, waiting. So the next time a whale falls into the trench, and the lightless silt begins to shift, and the scavengers stir from their burrows, remember the isopods, remember their armor, their silence, their age, and remember that the deep doesn't just hold monsters, it holds caretakers, archivists, living fossils with armored shells and bottomless stomachs, designed not to conquer, but to endure. And that endurance is what makes them so dangerous, because they will outlast us, just as they outlasted the trilobites, the dinosaurs, the ice, and everything we thought we knew about life on Earth. They are not here to thrill. They are not here to inspire. They are here to clean the bones when we're gone, and they will. In the end, everything falls, and the armored ones, they will be there, waiting in the dark. Story 9. The Giants of the Abyssal Mud. Living fossils with armored shells and bottomless stomachs, designed not to conquer, but to endure. And that endurance is what makes them so dangerous, because they will outlast us, just as they outlasted the trilobites, the dinosaurs, the ice, and everything we thought we knew about life on Earth. They are not here to thrill. They are not here to inspire. They are here to clean the bones when we're gone, and they will. In the end, everything falls, and the armored ones, they will be there, waiting, in the dark. But not everything that waits in the dark is armored. Some things, the strangest things, are soft, delicate, and impossibly alive in ways we struggle to comprehend. We now turn our attention from the heavy-footed scavengers that roam the abyssal slopes to something far more fragile and far more mysterious. A creature with no eyes, no mouth, no bones, and no brain. A single cell. And yet, it is among the largest organisms in the deepest parts of the ocean. Let's descend into the Hadal Plains once more, nearly 7 miles beneath the surface, to a place where monsters don't roar or chase or feed. They simply grow. This is the story of the Xenophyophores, giants of the abyssal mud. They are not the kind of creature that makes headlines. They do not shimmer. They do not strike. They do not move in any way we would call movement. And yet, when scientists first encountered them in the Mariana Trench, they paused, then stared, then questioned everything they knew about what a cell could be. Because these were not ordinary microbes, these were giants. In 2011, nearly 10.6 kilometers below the surface of the Western Pacific, a team of scientists operating a deep-sea submersible made an astonishing discovery. Nestled in the soft sediment of the Challenger Deep, Earth's deepest known point, were scattered pale globular forms, each eerily still, like alien spores scattered across a lifeless moonscape. They measured over 10 centimeters across, the size of a baseball or a human fist. And yet, each one was a single cell, not a colony, not a cluster. One cell. These were xenophyophores, organisms whose very existence defies expectation. Their name comes from Greek, xeno, meaning foreign, and phaeophore, meaning bearer of pods. But in truth, no name does them justice. They are amoebas, at least in classification. But calling them amoebas is like calling a blue whale a fish. Technically close, but cosmically wrong. To find them in the Mariana Trench was astonishing. To find them thriving was something else entirely. The Hadal Zone, that inky underworld from 6,000 meters and deeper, is one of the most extreme habitats on Earth. Pressure at these depths surpasses 1,000 times that at the surface. Temperatures hover just above freezing. Sunlight is not just absent, it has never touched these places, not once, in the entire history of life on Earth. And yet, the xenophyophories endure. They don't just survive, they thrive. And in doing so, they challenge one of the most fundamental assumptions in biology. That complexity arises from complexity. Because here, in the very deepest trenches of the ocean, the simplest of all living units, the cell, has become enormous. The first xenophyophore ever discovered was found not in the Mariana Trench, but in the Eastern Atlantic over a century ago. But for decades, they were dismissed as oddities, poorly understood and rarely studied. It wasn't until high-resolution imaging and deep-diving ROVs became commonplace that scientists began to realize something unsettling. These creatures weren't rare. They were everywhere. And in some parts of the deep sea, they were among the dominant life forms. In certain abyssal plains, xenophyophories can number thousands per square meter. Their shapes vary. Some look like leaves. Others resemble branching trees, lacy fans, or tangled nets. Some lie flat and circular. Others rise like sculptures from the mud. Each one built from particles scavenged from the surrounding seafloor. Bits of sediment, shell, and detritus glued together in a strange alien casing called a test. Inside that test is the cell. It snakes and threads through the structure like a slow-moving river of living cytoplasm. No organs, no nerves, no central coordination. Just a gelatinous life form sprawling through its own handmade architecture, reacting to the world at the speed of chemistry. This simplicity becomes surreal, because here, at pressures that can pulverize steel, the xenophyophores are some of the only visible life forms. They sit half buried in the mud, silent and soft, watching nothing, and growing. But their silence is deceptive, because xenophyophories are not passive bystanders. They are engineers of the deep. They shape the sediment. They absorb heavy metals, uranium, lead, mercury, in quantities that would kill almost anything else. They provide habitat for countless micro-creatures, tiny worms, crustaceans, and bacteria, which live, feed, and hide within their fragile bodies. Some scientists even believe xenophyophories may act as oases in an otherwise barren world, hubs of activity in the stillness of the abyss. A single xenophyophore may play host to dozens of other species. It is, in a way, a micro-ecosystem, a living continent in miniature. And yet, it is still just one cell. How does something so simple become so vast? This is the question that haunts biologists. In theory, a single-celled organism should be constrained by surface area. As a cell grows larger, it struggles to move nutrients and waste efficiently across its membrane. That's why most cells, from bacteria to blood cells, are microscopic. But xenophyophores circumvent this with a trick of architecture. Their cytoplasm is not one solid blob. It spreads out in thin threads and sheets through the nooks and crannies of their test, like nerves through a building. This allows them to increase surface area without increasing volume, maximizing diffusion while minimizing internal stress. It is an elegant alien solution, and one that seems uniquely suited to the deep sea, because here there is no sunlight to outrun, no predators to evade, no rush to grow fast or move far, only patience, and the slow dance of molecules. In this stillness, simplicity becomes an advantage. The very things that would kill a more complex creature, the pressure, the scarcity, the isolation, become irrelevant. The xenophyophore is immune to time. And perhaps that's what makes them so strange, because we like to imagine that evolution moves toward complexity, toward consciousness, toward intelligence. But here, in the world's deepest trench, life went the other way. It simplified, streamlined, and grew outward into a silent behemoth of mud and memory. Some xenophyophores live for decades. Others may persist for centuries, their soft tests slowly accumulating the detritus of the ages. In the fossil record, similar forms have been found dating back hundreds of millions of years. Some paleontologists believe xenophyophores, or their ancestors, may have been among the first visible animals on the seafloor. They are, in essence, living fossils, not because they resemble ancient creatures, but because they never needed to change. They are as old as they are alien, and they may hold secrets we're only beginning to grasp. In recent years, researchers have begun to study xenophyophores for more than their size. Their ability to concentrate metals has drawn interest from those studying bioremediation, the process of using living organisms to clean up pollution. Their unique structure makes them ideal for studying microbial colonization, and their slow, passive existence is a model for understanding extremophile survival. But there's another, stranger angle. Some scientists believe that xenophyophores may offer clues about life on other planets, because if a single cell can thrive and grow enormous at the bottom of Earth's deepest trench, then perhaps somewhere in the frozen oceans of Europa, or the methane lakes of Titan, or the dark seas of some distant exoplanet, something similar might exist, not as a predator, not as a builder, but as a patient witness to time, a quiet, pulsing being, built of softness and silence. And if we ever meet such a thing, it may not speak, or move, or think in any way we recognize, but it will live, just as the xenophyophores do. The idea is unsettling, because we often define life by motion, by hunger, by intelligence. But in the abyss, life is defined by persistence, and xenophyophores persist. They are not beautiful in any traditional sense. They are not frightening, but they are wrong. Wrong in the way that makes you question everything. How can a cell be so large? Why does it absorb poison? Why does it host life without intention or design? And why are there so many of them? Are we looking at creatures, or structures, or something in between? No one knows for sure. What we do know is that they are everywhere, lurking just beneath the soft mud of the trench floor, fragile, motionless, and utterly other. When ROVs sweep their cameras across the Hadal Plains, the xenophyophores appear like ghosts, half buried, half formed, like thoughts that never finished becoming. And perhaps, in a way, that's exactly what they are. Life, unfinished. Life, paused at the edge of complexity and content to stay there, watching, waiting, slowly accumulating the dust of a world that forgot they were here. And when we send our probes down, and when we finally touch the soil of the trench, it is their world we touch first. Not the fish, not the predators, but the giants of the abyssal mud, the quiet ones, the soft ones, the ones that have seen everything and needed nothing. Not all monsters have teeth. Some are made of patience, of silence, of time, and they are still down there, larger than they should be, older than we expect, and far, far stranger than we're ready to understand. We may think of them as strange, as alien, but to the trench, they are home, and to us, they are a reminder that even in the darkest places, life finds a way. Not always loudly, not always beautifully, but undeniably, unforgettably, and always, in forms we never saw coming. In the Mariana Trench, even the smallest things are enormous, and even the simplest things are wrapped in mystery. Story 10. The Bathyscaph Descent. What was seen in 1960? From the gelatinous silence of the xenophyrophoras, those strange, oversized amoebas who feed on heavy metals and drift through the trench like ghostly sentinels, we descend deeper still, not physically, but chronologically, into a moment when humankind dared to breach the trench's ultimate boundary, before we knew of the biotwangs and the translucent scavengers, before we had the cameras, the probes, and the remote arms to collect samples. There was only steel and nerve. This is not just the story of reaching the bottom of the world. It's the story of what was seen and what wasn't said. The year was 1960. The world was brimming with post-war ambition, and the oceans, so vast, so unclaimed, offered the next great challenge. The Cold War simmered in the background, a contest of technologies and frontiers. And while the skies were being conquered by rockets and satellites, a different kind of exploration stirred in the depths below. Enter the Trieste, a vessel unlike anything before it. Less a submarine and more a pressure capsule suspended in a metal balloon. A bathyscaph designed not for speed nor elegance, but survival. Its mission, to reach the bottom of the Challenger Deep, a point so remote and so extreme that, until then, it had never been visited by human eyes. It was Earth's most unreachable place, a pit at the edge of the known world. Inside the cramped sphere sat two men, Jacques Picard, a Swiss oceanographer and engineer, son of a balloonist, born of a family of explorers who had looked both skyward and downward. Calm, inquisitive, and cautious. Beside him, Lieutenant Don Walsh of the United States Navy, a submariner by training, pragmatic and precise, chosen for his composure and experience with deep-diving craft. Together, they formed an unlikely pair. Different backgrounds, different temperaments, yet both driven by the same unyielding curiosity. What lay at the very bottom of the sea? The descent began just after sunrise on January 23, 1960. The Trieste slipped below the waves south of Guam, tethered to no ship, carried downward only by gravity and the ballast of thousands of pounds of iron pellets. Its massive gasoline-filled float chamber provided buoyancy. Its spherical crew cabin, made of thick steel, was the only thing keeping them alive. As the surface light faded, the temperature dropped. The windows dimmed to black. The radio connection with the surface crackled, then fell silent. The world around them narrowed to a tiny, pressure-sealed bubble hurtling through 36,000 feet of water. Every creak of the hull, every pop of contracting metal, a reminder that they were not just visiting the deep, they were trespassing. And the deep does not give welcome lightly. 5 hours passed. 5 hours of descent into unbroken blackness. And then, the jolt. At a depth of roughly 30,000 feet, a sharp crack echoed through the chamber. One of the exterior plexiglass viewing windows had fractured. Not breached, but stressed. The force outside was over 16,000 pounds per square inch. There could be no repair, no escape. If another piece failed, they would be crushed instantly. But they continued. Another 6,000 feet, slower now, more deliberate, until finally, the Trieste settled, 35,114 feet below sea level, the Challenger Deep, the bottom of the world. What they saw through the port was nothing. At first, a flat, greyish sediment plain, lifeless, colourless. Their lights revealed silt clouds drifting like smoke in a windless room. No coral, no rocks, just endless clay. But then, movement, a shape in the silt. Not fast, not predatory, but unmistakably alive. Picard would later describe it as resembling a flatfish, something akin to a sole or flounder. Perhaps 12 inches long, it wriggled slightly, disturbing the dust, then disappeared behind the gentle plume of their landing. It was a revelation. No one had believed vertebrate life could survive such pressure. Some had hypothesized that proteins would denature, that cell membranes would collapse. But here it was, a fish, or so they claimed. Because later, the story changed. In the official reports, the sighting was noted, but briefly, almost dismissively. Skeptics would argue that what they saw was likely a holothurian, a sea cucumber, or perhaps an illusion created by the disturbance of their own descent. But in private, Picard's tone was different. His personal journals, recovered years later, hinted at something stranger. His wording became hesitant, careful. He spoke of a creature, not a fish. He remarked on its unusual behavior, its lack of apparent reaction to the massive disturbance caused by their arrival. Most notably, he never claimed to have seen it swim away, only disappear. There are rumors, never confirmed, that Picard, in his last years, confided something to a fellow oceanographer, that what he saw was not a fish at all, that it was watching them, not fleeing, not startled, observing. He would never put that in print. But some believe that was the real reason the dive was never repeated, at least not with humans, for over 50 years. It raises a question that lingers in the deepest parts of marine lore. What did they see, and what didn't they say? There's something about the bottom of the Mariana Trench that invites secrecy. Perhaps because it is so inaccessible, so removed from the human domain that what happens there, what's observed there, feels separate from our world. Some have speculated that Picard and Walsh were under strict orders not to disclose everything, that the US Navy, who funded and operated the Trieste, classified parts of the dive. There is precedent for this. Naval operations in the 1960s were deeply entwined with Cold War secrecy. The oceans were a strategic frontier. Anything unusual, especially anything that could not be explained, was to be kept quiet. And there's another detail, something that rarely makes it into public retellings. Picard and Walsh reported hearing sounds, faint but rhythmic, not geological, not the random creaks of the sub's metal frame, but pulsed, like sonar. Only it didn't match any known frequency, and it was coming from below them, below the deepest point on Earth. They dismissed it, or tried to. Perhaps it was an echo, a malfunction, but they recorded it in the logbook all the same. Then it was forgotten, until 1995, when a NOAA hydrophone array picked up an identical pattern in the Western Pacific. The recording was clearer this time, the same rhythmic pulse, low, deliberate. But by then, Picard was gone, and Walsh refused to comment. Theories abound. The mainstream explanation is simple. It was a misidentification. Under the stress and isolation of the deep, the human mind sees patterns. A fish becomes a shadow. a sound becomes a message, but others aren't so sure. Marine biologist Dr. Evelyn Muro has spent decades studying deep-sea acoustics. In 2006, she gave a now-forgotten interview where she claimed to have analysed the Trieste dive logs, not the publicly available ones, but the internal Navy copies. She said they were redacted, heavily, entire pages blacked out, references to biological anomalies, mentions of motion near landing zone, and most chilling of all, a line that read, "Contact maintained visual for 11 seconds, no identifiable anatomy, possible dermal sheath, no tail." When pressed for proof, she declined to elaborate. She died 2 years later in a diving accident off the coast of Chile. Her notes were never found, and yet, the rumours persist. There are those who believe that what the Trieste encountered was not just unusual, but unique. A life form not yet classified. A creature that exists only at that pressure, that depth, and that has adapted not merely to survive, but to avoid being seen. Something large enough to be noticed, but still. So still that it could be mistaken for part of the terrain. A being of the deep, a watcher. One speculative paper, published in a fringe oceanography journal, even coined a name for it, Abyssopelagonix. The suggestion was that it is a symbiotic colony organism, not unlike a siphonophore, that it mimics the trench floor, lying dormant for decades between energy inputs, rare falls of organic material, or deep-sea disturbances like the descent of a submersible. The authors were ridiculed, but the idea lingers, especially when you consider that no one has ever duplicated what Piccard and Walsh saw. James Cameron's solo dive in 2012 was technologically superior. He had better cameras, better lighting, more time on the seafloor. And yet, he saw no fish, no movement, just silt. Cameron himself remarked on it. In a press conference, he said, "It was beautiful, empty, peaceful, but I kept thinking it felt like something had been there, just not anymore." He later clarified that he meant no mystery by the comment, but in interviews, he's admitted to being haunted by the dive, haunted by the silence. So what are we left with? A flatfish, a shadow, a sound, a few cryptic remarks in an old journal, and an ocean that guards its secrets more tightly than any vault. There's one last detail worth mentioning. When the Trieste began its ascent, after 20 minutes on the bottom, the external thermometer registered a brief spike. Just 2 degrees, not much, but anomalous. The heat could have come from the Bathyscaph's lights, or from disturbed sediment, or it could have come from something living, something warm, something moving. We'll never know. And perhaps that's the way the deep prefers it. Not all encounters are meant to be understood. Some are meant to be remembered, quietly, to be passed along as a whisper, a journal entry, a half-remembered shape in the dark. The Bathyscaph Trieste did more than reach the deepest point on Earth. It touched something older, something watching, and in return, it was watched. Even now, as explorers prepare new missions to the trench, the question lingers. What waits at the bottom? Not what we expect, not what we've seen, but what we've only felt. A pressure deeper than water, a silence louder than sound, and a gaze that never blinks. The Trieste returned to the surface. The men inside survived. But the trench, it stayed behind. And so did its secrets. Story 11. The Biotwang Anomaly. Unnatural sounds in the deep. From the silent gaze of the Challenger Deep, we descend even further, not in depth, but in meaning. For not all mysteries of the trench are things we've seen. Some are things we've heard. Because while the ocean's darkness is eternal, it is not quiet. In 2014, something stirred in the Western Pacific. It didn't crash or rise or shimmer. It sang. And what it sang, no one could explain. It began as a low moan, faint but rising, like metal groaning against pressure, like a siren under steel. It echoed upward from the trench floor in a long, resonant cry, and then pierced the dark with something sharper, a twang, like a taut cable snapping in slow motion, like machinery calling out in song. And just as quickly, it disappeared. The sound was not a one-time anomaly. It had a pattern, a rhythm. It returned, and scientists would come to call it the Western Pacific Biotwang. Take a listen. Recorded at nearly 3,000 feet and echoing from even deeper, this strange sound haunted the hydrophones of NOAA researchers listening to the Mariana Trench. They weren't listening for the extraordinary. They were charting whale migrations, tectonic movements, and ocean currents. But what they caught instead was something unlike any whale song, something unlike any earthquake, something that didn't fit. A 5-second burst of layered acoustic energy, low frequencies, high-pitched resonance, mechanical distortion, and a crescendo that felt more like a performance than a signal. It was as if something was out there, something alive, or something built, and it had a voice. The biotwang wasn't entirely new. It had been heard before, faintly, distantly, in recordings dating back to 2012. But it wasn't until 2014 that it was captured in full fidelity, that researchers could examine its waveform and realize it didn't belong to anything they recognized. No known biological source matched the frequency curve. No geological pattern could mimic the rise and fall. And no human craft had been in the area. The ocean, it seemed, had produced a sound with no name. The Mariana Trench is not a quiet place. Contrary to what we might imagine, it's filled with noise. Distant rumblings, the grinding of tectonic plates, the slow hiss of hydrothermal vents. Even life makes itself known. Sperm whales dive deep into the abyss, clicking and chirping as they hunt. Beaked whales descend in silence and then burst into rapid vocalizations. Shrimps snap their claws with explosive force, but all of those sounds are mapped, identified, expected. The biotwang was none of those. Its strange metallic quality stood out immediately. Even among seasoned researchers, the tone was jarring. It sounded unnatural, not because it was artificial, but because it didn't seem to come from any world we knew. Some called it mechanical, others biological, but unfamiliar. It was both haunting and precise, as if the trench had learned to speak. Its cadence bore resemblance to baleen whale calls, in the sense that it rose in tone and complexity, but its structure was unlike any cetacean. Blue whales, the giants of the ocean, produce low, sustained pulses. Humpbacks sing in elaborate sequences, but nothing known produced a sound that warped across octaves so suddenly, so cleanly, and with such unnatural timbre. If it was a whale, it was one we'd never heard before. If it wasn't a whale, then what was it? Some researchers speculated that it could be the call of the elusive minke whale, a species known to produce pulse trains and boing-like sounds in the Pacific. But minke calls, though strange, have a signature, and the biotwang didn't match it. Others suggested a geological explanation. Could it be the groan of a shifting tectonic plate? A landslide echoing through the trench walls? Maybe, but those events produce broadband noise, not tonal resonance. The biotwang had pitch, and more than that, it had modulation. It sounded controlled, not like rock shifting against rock, but like something tuning its voice. If this was geology, it was unlike any known event. Then came the stranger theories. Some pointed to the possibility of unidentified submerged objects, USOs, operating in the trench. The ocean is vast and largely unmapped. Military sonar has reported fast-moving anomalies in deep waters for decades. Could the biotwang be a byproduct of propulsion, a form of navigation, communication? Those who entertain this theory point to the location. The sound emanates from the Mariana Trench, a place where few have access and even fewer go unobserved. If something advanced were operating down there, the remoteness would be perfect cover. But skeptics push back. There's no direct evidence of USOs, and even if such technology existed, why would it produce such a peculiar acoustic signature? Why repeat it? Why sing? Because make no mistake, the biotwang repeats. It's been recorded again, not constantly, not predictably, but it returns. And each time, its shape is the same. The same rise, the same twang, the same low moan at the end. It isn't noise, it's a pattern, which leads to a haunting question. What in the trench is repeating itself? There is another possibility, one even stranger, one that sits somewhere between biology and technology: communication. The ocean is filled with languages we do not understand. Coral reefs communicate chemically. Squid use patterns of color and light. Whales use long-distance calls that span hundreds of miles. What if, deep within the trench, something else is speaking? What if the biotwang isn't a call or a cry, but a statement? The structure of the sound lends itself to that theory. A prelude, a peak, a resolution, almost like a sentence. If this is true, then what we're hearing may not be an isolated signal. It could be part of a larger system, a conversation. Between what? That no one knows. Because the trench is vast, and our understanding of it, even now, is shallow. Less than 0.05% of its total area has been explored with manned vehicles. The rest is darkness. The kind of darkness where things go unseen and unheard, except for when they choose to reveal themselves. The biotwang isn't alone. In 1997, the National Oceanic and Atmospheric Administration recorded a different sound, one so loud it was picked up across multiple sensors thousands of kilometers apart. They called it the bloop. At first, the bloop was suspected to be man-made, a submarine, a test, but the sound had no artificial harmonics. It didn't repeat, and its spectral signature was organic. In fact, it resembled an animal, but one far larger than anything known. To this day, the bloop remains unexplained, though some suggest it was the sound of ice fracturing deep in the ocean. Still, the resemblance to biological sounds is uncanny, and it echoes the same uncertainty we feel about the biotwang. We're listening to the deep, and it's speaking back, but we don't yet understand the language. In 2016, another sound was recorded in the Mariana Trench. This one lower in pitch, a long modulating moan that lasted over 30 seconds. It came from the same region as the biotwang and carried some of the same tonal qualities. Researchers noted the harmonic structure, the layered overtones, the faint pulse at the end, and once again, it didn't match any known species. Was it the same source, a different one, or something mimicking the biotwang? Acoustic mimicry is known in nature. Birds do it, Whales do it. If something down there is imitating, learning, it suggests intelligence. Not just life, but mind. And if that's true, we may not be the only ones studying the trench. There's a strange kind of loneliness to the biotwang. A sound with no face, a voice with no speaker, like finding a song on a radio station that doesn't exist. It haunts the hydrophones not with volume, but with purpose. Something made this, and it made it again and again. The Mariana Trench is not just deep, it's ancient. Formed over 180 million years ago, it has existed longer than most land animals, long enough for evolution to play out, in silence, in darkness. Could something have emerged there? Something adapted not to light or even pressure, but to vibration. In a world without eyes, sound is sight, and the biotwang could be its way of seeing. There is one last theory, unpopular, speculative, but unsettling in its implications. Some researchers have quietly suggested that the biotwang might be artificial, not biological, not geological, but engineered. A sonar beacon, a coded pulse, a frequency meant to interfere or disguise. It's not a new idea. During the Cold War, militaries around the world used underwater sound as a shield, creating noise to block detection. Could the trench be hiding something behind its own echo? Could the biotwang be not a signal, but a veil? A way of saying, don't come closer, or worse, a lure. In folklore, sirens sang songs to draw sailors into the deep. What if, in some ancient way, the trench is still singing? Not for us, but for something that listens. We don't know what made the biotwang. We don't know if it's alive or artificial or something in between. But we know this. It wasn't an accident. It wasn't random. It had rhythm and resonance and repetition. It had intention. And that may be the most frightening part of all. Because in a place so deep, so dark, so untouched, where nothing should be speaking, something is, and it wants to be heard. The Western Pacific biotwang remains unsolved, a sound with no source, a question with no answer. But its presence reminds us. The trench is not empty. It listens, it speaks, it remembers, and sometimes it sings. So as we continue to send machines into its depths, as we lower cables and sensors and lights into the black, we must remember the trench is not silent. It is waiting. And when it sings again, will we be ready to listen? Or will we finally understand what it was trying to say all along? For in the ocean's deepest places, the loudest mysteries are the ones we can't explain, and the strangest voices are the ones that never go silent. Story 12. The balloon mouth eel and the ghost fish. From the spectral echoes of the biotwang, where sound itself seemed to pulse with alien intelligence from the bottomless trench, we now follow that vibration deeper, not in frequency, but in form. Not all mysteries call out in metallic moans. Some drift silently, their very bodies shaped by darkness and hunger. This next descent takes us beyond sound, into silence, to the realm of creatures so unlike anything on the surface that they appear more imagined than real. Here, in the blackest reaches of the Pacific, forms begin to shift. Limbs stretch into shadows, skin turns translucent, and mouths become vast, ballooning traps, gates to a world where shape and scale defy meaning. This is the story of the gulper eel and the ghost fish that followed behind it. At first glance, they appear fragile, wisps, spectres. Yet somehow, they endure what would destroy nearly every living thing, not with armor or strength, but with surrender. Surrender to the deep, to pressure, to darkness. Let us begin with the one that swallows worlds. The gulper eel, sometimes called the pelican eel, is a creature almost too strange to believe. It drifts through the mid-water zones of the ocean, vast spaces between the sunlit surface and the abyssal floor, where pressure is immense and food scarce. The first thing one notices is its mouth, not its teeth, not its eyes, but its impossibly vast, grotesquely oversized mouth. It balloons outward like a parachute or an empty sack, so disproportionate that it can stretch wide enough to engulf prey far larger than the eel itself. This mouth isn't just an opening, it's a trap, a net woven of flesh and instinct, inflated in a moment, collapsed in an instant. The gulper eel doesn't chase, it doesn't strike, it floats, mouth open, waiting for the ocean to deliver something worth swallowing. Its body is long, narrow, and whip-like, tapering into a tail so slender it becomes little more than a thread. At the very tip, a pink, bioluminescent bulb. Here in the abyss, where sight is useless and light is unknown, this glowing lure becomes its one form of deception. Some believe it pulses softly, like a heartbeat, or flashes erratically, mimicking smaller prey. Drawn toward the glow, smaller creatures approach, until they cross an invisible threshold, and then, without muscle, without warning, the gulper's mouth inflates. A vacuum, a net of skin, and in seconds, the trap is closed. What it catches, it swallows whole. Not just small fish and crustaceans, but even animals nearly its own size. It has no teeth meant for cutting, no jaws built for chewing. Its stomach simply stretches, expanding to contain whatever it can trap. A balloon, swallowing another balloon. But it's what comes next that adds another layer of unease. For despite its alien appearance, the gulper eel is a vertebrate, a cousin, distantly, to the familiar eels of coral reefs. Yet, over millennia, it has abandoned the familiar in exchange for something far more surreal. It has no scales. Its bones are barely calcified. Its body, gelatinous, more akin to jelly than muscle. Even its organs seem adapted not for strength, but for absence. Its heart is small, its blood minimal, its musculature weak, barely enough to move through the water. And perhaps that is the secret. It survives by giving in, by not resisting the pressure of the deep, but by yielding to it entirely. Its body is shaped by the void it inhabits, a ghost of form, suspended in an ocean where form no longer matters. Few have seen one alive. Fewer still have seen it feed. Most of our understanding comes from chance encounters, specimens pulled up in deep trawls, already damaged or dying. Even in death they seem unreal. Their bodies collapse, their balloon-like jaws folding like deflated parachutes, their skin pale and wet, glistening like something half-formed. And yet, they live. In 2018, a remotely operated vehicle captured one on camera in the Pacific Abyss. For a few haunting moments, we saw it in its element, undulating, drifting, glowing faintly, its mouth puffed outward like an umbrella, then closed, as if disappointed by what it hadn't caught. It was beautiful, alien, and deeply unsettling. But the gulper eel is not alone. Floating nearby, just as translucent, and even more spectral, drifts another enigma, the ghost fish. In 2016, a robotic sub descending into the depths of the Mariana Trench captured something that had never been seen alive before. a creature known only from lifeless museum samples, suddenly appearing in motion. It looked like smoke, a pale ribbon hovering just above the seafloor. No scales, no pigment, only a hint of structure, as if someone had drawn a fish in chalk, then smudged the lines. Its name is Aphionis gelatinosus, a mouthful for a creature that seems too delicate for even language to hold. Until that moment, this fish had only been known through preserved remains, bodies pulled from the deep and stored in jars, shrunken and warped by pressure change. But now, here it was, alive, gliding silently across the trench floor. Its body was soft, gelatinous, barely more than a membrane. Fins so thin they seemed to disappear in the current. Eyes reduced to pale orbs. Blind, perhaps, or nearly so. It didn't swim so much as it hovered, riding invisible currents like a feather on wind. This was not a hunter, not a predator. It was something else entirely. A passenger. Its life is a study in reduction. No scales, minimal muscle, skeleton lightened and reduced. Even its swim bladder, the organ most fish use to control buoyancy, is absent. Instead, it floats through biochemical balance, suspended perfectly in place. Why evolve this way? Why abandon strength for softness, form for formlessness? Perhaps because here, in the trench, rigidity is a weakness. Anything hard shatters, anything sharp breaks. Only the flexible survives. The ghostfish has no need for speed. Its food is scarce, drifting particles, microbial mats, tiny invertebrates barely visible to the eye. And so it floats, waiting, drifting. It is, in a sense, the deep itself made flesh. And yet it thrives. Against all logic, these fragile creatures endure the most extreme environment on Earth. Temperatures near freezing. Pressures so immense they would crush a human body flat in an instant. Darkness so complete that not a single photon of sunlight can reach them. And yet, they are here. In 2022, another ghostfish was filmed at even greater depths, nearly 8,200 meters below the surface. It drifted in slow spirals, translucent as glass, almost unaware of the camera watching it. Scientists were stunned, not just by its appearance, but by what it represented: a vertebrate, surviving where none should. Because beyond a certain depth, proteins begin to break down. Cell membranes become unstable. The laws of biology itself begin to crack. And yet these creatures persist. Some speculate they use unique chemical adaptations, molecules that prevent their cells from rupturing under pressure. Others point to their slow metabolism, an evolutionary trade-off that sacrifices speed for resilience. But none of this fully explains the elegance of their design. They seem engineered not for life, but for survival in death's kingdom, as if the deep had sculpted them as its emissaries. There are many theories that these creatures evolved from shallow ancestors who were slowly pushed deeper, that their lack of pigment is an adaptation to permanent darkness, that their gelatinous bodies help conserve energy in a place where meals may come only once in a month. But none of these answers explain what it feels like to see one, to witness a creature so utterly divorced from surface life, so alien in motion and form, that it seems more spirit than animal. And perhaps that's the truth of it. These are not monsters, not horrors, but ghosts. Ghosts of biology, ghosts of possibility. And they remind us that the ocean is not just a place of depth, but of forgetting. It forgets shape, it forgets light, it forgets rules. What remains is what can survive forgetting. The gulper eel, the ghostfish. Two forms adrift in the same eternal night, one built to consume, the other built to endure. But they are not alone, for in recent years, strange sightings have begun to accumulate, not just in footage, but in the records of sonar arrays. Sudden blips, unexpected shadows, movements too large for known species, and too soft for machines to recognize. Some believe these may be new species of deep eels. Others, something older. In 2020, an ROV operating near the Yap Trench, west of the Mariana, captured something faint on camera. A long, pale shape undulating just beyond the range of its lights. Too far for detail, too close to dismiss. It moved like a ribbon, but its size was wrong. Estimates suggested it might have been over 3 meters long, and it never reappeared. Some say it was a gulper eel, of unusual size. Others, an undiscovered ghostfish variant. And still others whisper something more, that perhaps we are only seeing fragments of larger bodies, or of species so unlike our taxonomies that we cannot name them at all. The deep does not reveal its forms easily, and what we call species may be illusions, lines drawn across the shifting sands of evolution. Perhaps these creatures are not new, but old, very old, survivors from an age before sunlight, before bone, before the surface even knew life. Echoes of prehistory still drifting, their bodies unchanged because change is death. No fossils can confirm this. No bones have been found. But that too is telling. These creatures do not fossilize. Their bodies collapse in seconds when brought to the surface. They leave no record, no mark, only questions. And so we drift with them, as our cameras rise back toward the light, as the pressure lifts and color returns. We must ask, what else waits down there? What other shapes have we missed? What other lives have slipped between our nets, too soft to grasp? For every gulper eel seen, how many pass unseen? For every ghostfish filmed, how many drift alone, unknown, unseen? We call them strange, we call them rare, but perhaps we are the rare ones, creatures of light, floating on the skin of a world whose heart is darkness. The gulper eel expands its mouth, a balloon of hunger. The ghostfish glides silently past, a whisper in water. And the trench watches. It forgets nothing, only hides. So the next time we lower our machines into the black, we should not ask what we'll find. We should ask, what will allow itself to be seen? For some truths are soft, translucent, and they slip through our fingers like ghosts. Story 13. The Vampires of the Abyss and Dumbo's Domain. Not all ghosts drift silently through the water. Some shimmer like ink in the dark and pulse with light that never warms. Some move without muscle, flow without form, drifting like thoughts across the ocean's mind. In the deep, there are creatures stranger than fish, more elusive than sound. They flash and vanish. They glide and fold. And some look back. In the aftermath of the ghostfish, a pale wisp sliding past our lenses, and the gulper eel, with its grotesque mouth blooming like a balloon from a void. We now turn to the ones that don't just survive the abyss. They dance through it. They hide in plain sight, cloaked in velvet, crowned with fins that resemble ears, or flinging glowing mucus in the face of their enemies. These are not monsters in the traditional sense. They don't lunge, they don't bite, but they haunt us nonetheless, because something about them feels impossible. The vampire squid, the Dumbo octopus, Two beings that dwell in the twilight between known and unknown, neither frightening nor fragile, and yet unmistakably alien. Let's follow their trails through the midnight water and see what secrets they've left in their wake. Far beneath the last flickers of sunlight, where pressure crushes most dreams before they form, lies a region of the ocean known as the oxygen minimum zone, a strange middle layer between 2,000 and 3,000 feet deep. Here, oxygen levels plummet, photosynthesis is impossible, and few predators dare to patrol the gloom. It's a place of scarcity, a world of compromise. And yet, the vampire squid thrives here. Despite its name, Vampiroteuthis infernales, literally vampire squid from hell, is no vampire at all. It doesn't suck blood. It doesn't hunt like other cephalopods. In fact, it doesn't even kill its food. Instead, the vampire squid survives by scavenging marine snow, tiny flakes of organic detritus that drift down from above like a perpetual snowfall of decay. Dead plankton, fecal pellets, mucus, and fragments of flesh. To most animals, this detritus is useless, debris discarded by the living. But to the vampire squid, it's a banquet. It uses long, hair-like filaments to capture the particles, rolling them into sticky balls and guiding them to its mouth. No chase, no violence, just patience. But what makes this creature so unforgettable isn't its diet, it's its design. Imagine a being no larger than a football, cloaked in deep red or black skin, with eyes proportionally the largest in the animal kingdom, glowing blue or red depending on how they reflect light. Its arms are connected by a web of skin, forming a cape or umbrella that it can wrap around its body like a shield. And when threatened, it performs a maneuver unlike anything else in nature. It inverts itself. Flipping its arms over its body, it reveals a spectacle of sharp-looking, fleshy spines. These aren't actually dangerous, just soft projections. But to a predator, they look like a mouthful of daggers. This pineapple posture, as researchers call it, is both illusion and defense, a way to frighten without force. If the threat continues, the vampire squid deploys something even stranger. Not ink, but light. Instead of clouding the water with dark pigment like most squid, it releases a shimmering blast of bioluminescent mucus, a glowing cloud that drifts and pulses like a living fog. The light lasts for several minutes, leaving behind a ghost trail, a decoy. While the predator investigates the sparkle, the vampire squid drifts away, disappearing into blackness. It doesn't flee in panic. It floats, because movement is costly in the deep sea, and the vampire squid is an energy miser. Its metabolism is among the lowest ever recorded in any cephalopod. Its muscles are weak. Its blood carries little oxygen, but it doesn't need more. It was born for this twilight world. Neither fully squid nor fully octopus, the vampire squid is the last living member of its own ancient lineage. A lineage that dates back 300 million years. That's older than the dinosaurs. Older than flowering plants. A survivor not because it's fierce, but because it's gentle. Because it asks for little, disturbs nothing, and waits. A creature that does not fight the dark, but flows with it. But not all things in the deep are shadows. Some, somehow, are joy. If the vampire squid is a study in defense and detachment, then the Dumbo octopus is a quiet ode to grace. It's difficult to describe the first impression people have upon seeing a Dumbo octopus. Words like cute and delicate are common, but they don't quite capture the strangeness of it. Because while its fins do resemble the oversized ears of Disney's famous elephant, the resemblance ends there. There is no circus here, no applause, only a quiet, gentle drift in eternal dark. Grimpertoothus, the genus that includes Dumbo octopuses, inhabits depths as great as 13,000 feet, and in some cases, even deeper. These are some of the deepest dwelling octopuses ever discovered. Unlike their shallow water relatives, they don't dart or ink. They don't cling to rocks, and they don't use jet propulsion unless absolutely necessary. Instead, they pulse their fins, slowly, rhythmically, like wings moving through invisible air. They hover above the seafloor, their arms curled delicately beneath them, webbed like a dancer's skirt, and they glide, not hunting, not fleeing, just drifting. Their bodies are soft, gelatinous, fragile, even translucent at times. Some shimmer with shades of peach or lavender under artificial light. Others remain pale and ghost-like, the color of candle wax left too long in the cold. They feed on copepods, worms, and small benthic crustaceans, scooping them gently from the sediment. Their mouths are hidden, their movements slow. There are no sharp claws, no aggression, and yet they persist in some of the harshest environments on Earth. How? Perhaps because, like the vampire squid, they have embraced the strategy of softness. There is no armor to crack, no skeleton to break, just water, moving within water. Some Dumbo octopuses have been spotted curling their arms into a tight ball, then unfurling like a blooming flower. Others spiral through the water, turning pirouettes that seem less about survival and more about being. It's as if their very nature defies the premise that life must struggle to endure. In the 1990s, as remotely operated vehicles began to explore greater depths, sightings of Dumbo octopuses increased, though they remained rare. Each encounter seemed to stir something in those who watched. These weren't monsters, they weren't relics. They were something else, something serene, like clouds in a stormless sky. And yet, despite their gentle appearance, Dumbo octopuses are no evolutionary accidents. They're not weak, they're not failing, they're simply optimized for stillness. Their bodies are nearly neutrally buoyant. Their movement expends almost no energy, and they can tolerate immense pressure without damage because there's nothing rigid to crush. Softness, once again, proves its power. But perhaps the most haunting truth is this: we've barely begun to understand them. For all our technology, our submarines, our deep-sea cameras, we've only seen fragments. A glimpse here, a movement there. As of now, we've identified fewer than 20 species in the Grimpertoothus genus, and most were described from a single specimen. No one knows how long they live, how they reproduce, what drives their migrations. We don't know if they sing in frequencies we can't hear, or if they feel the rumble of tectonic plates as pulses of music through the sea. They are mystery suspended in silence. And so, we turn our gaze back, outward, into the dark. And we ask again, why do creatures like these exist? Why would evolution, so often associated with competition and conflict, give rise to animals that are gentle, soft, and slow? Perhaps because, in the deep sea, the rules change. Here, aggression is wasteful, speed is dangerous, and stillness is survival. The vampire squid and Dumbo octopus aren't mistakes. They're not evolutionary leftovers. They are masterpieces carved by pressure and time. Silent dancers in a world of silence. And when we peer down into their world, from our submersibles and screens, we don't just see biology, we see poetry. Because in a universe that seems to favor strength and conquest, these creatures are living proof that gentleness can endure. They are reminders that some of the most enduring forms of life are the ones that float, that pulse, that glow, that hide in plain sight. And when we ask what else is down there, beneath the weight of miles of water, the answer may be more wondrous than we're prepared for. Not monsters, not threats, but quiet, living questions. Eyes that see and do not flee. Fins that glide and do not tear. Forms that defy gravity, aggression, and even definition. Perhaps the abyss is not as empty as we feared. Perhaps it is full of gentleness we don't yet understand, of creatures we'll never catch, and of truths that shimmer, just out of reach. So, as we drift onward, deeper still, let us carry their memory. The vampire that doesn't feed, the octopus that dances in the dark, and the thought that even in the harshest depths, something soft survives. Story 14. The Kraken Unveiled. From the soft, silent folds of bioluminescent arms that curl like drifting paper beneath 1,000 tons of water, we emerge now into a darker tale, one written not in gentle pulses of light, but in fear, folklore, and the flick of a tentacle too large for reason. The vampire squid and Dumbo octopus taught us that not all beings of the deep are hostile. Some dance, some glow. Some survive simply by avoiding conflict altogether. But legends from the surface have long whispered of something else beneath the waves. Something massive, something watching, not a dancer, but a hunter, not gentle, not slow, but sudden, coiled, explosive. A creature so immense it could drag ships into the abyss, or so the old sailors said. And for centuries, science scoffed. There was no proof. Only tales told over tankards of rum, passed from trembling lips to skeptical ears. Only sketches, only fear. But then, in the early hours of a quiet morning in 2006, a camera flickered to life in the deep, and for the first time in recorded history, a legend stirred. This is the story of the Kraken made real. The giant squid, no longer a sailor's hallucination, but a creature of flesh and blood, and unimaginable scale. Its scientific name is Architeuthis dux, but names mean little when you're 15 meters long, with eyes the size of dinner plates, and arms lined with hooks. To understand why this creature inspires such awe and such fear, we need to look back, centuries before the lens ever found it. In the age of wooden ships and wind-battered sails, men ventured farther than they understood. The sea, vast and unknowable, swallowed whole fleets in silence. And from those disappearances came stories of shadows beneath the waves, of arms like ropes curling from the deep, of whirlpools not formed by wind or current, but by limbs dragging the helpless downward. The Norse called it the Kraken, a monster so large it was mistaken for an island until it moved. Sailors from the 12th century described it rising from the depths to wrap itself around a ship, pulling it under with shocking speed. These accounts weren't isolated. French, Dutch, Portuguese, Japanese. From every corner of the seafaring world came echoes of the same thing. A terror in the water, tentacled, titanic, hungry. Illustrations from medieval bestiaries show a creature with a bulbous body, long curling limbs, and a beak like a monstrous parrot. But despite the vivid detail, science had no interest in legends. That began to change in the 19th century. In 1857, Danish naturalist Japetus Steenstrup gave the creature a name, Architeuthis. He based it not on sightings, but on remains, beached carcasses, tentacles in the bellies of whales, and strange round scars found on the heads of sperm whales, each mark matching the suckers of an enormous squid. Steenstrup wasn't alone in his curiosity. That same year, newspapers across Europe and North America exploded with reports. A giant squid had been spotted off the coast of Newfoundland. Local fishermen claimed it wrapped itself around their boat, thrashing and pulling until they hacked it loose with axes. Pieces of the animal were brought ashore, tentacles nearly 20 feet long, and slowly doubt began to waver. Could the Kraken be real? After all, by the late 1800s, sightings turned into discoveries. Dead giant squid began washing up on coasts around the world. Stretched out across beaches, their pale flesh bloated, their eyes clouded, they were no longer just phantoms. They were specimens. But something was still missing. No one had ever seen one alive. No one had captured it in motion. The Kraken, though real, remained a mystery, a ghost of science, confirmed only by death. What's more, every specimen retrieved was damaged, decaying, or partially eaten. Their gelatinous bodies didn't survive well on the surface, and the pressure of the deep distorted what little we could learn. How did they hunt? How did they live? Were they solitary or legion? No one knew. And that silence, that absence, allowed the myth to survive. Because if they were real and alive, then they were still out there, watching, waiting. But science, for all its limitations, is persistent. In 2004, Japanese researchers T. Kubodera and Kei Mori began a series of daring attempts to capture a giant squid in its natural environment, deep in the waters off the Ogasawara Islands. Using a system of baited hooks, long cables, and still cameras set to automatically photograph movement, they spent months dropping their equipment into the pitch black. And then, on September 30th, 2004, one of their hooks was taken. What followed were 556 images. They didn't show a monster attacking. They didn't show chaos or blood. Instead, the pictures revealed a graceful, otherworldly creature coiling around the bait with astonishing speed. It was long, it was pale, and it was unmistakably a giant squid. This was the first time a living Architeuthis had been captured on film in its natural habitat. But the true breakthrough came in 2006. Kubodera and his team returned to the Ogasawara Islands. This time, they brought a video camera. Using new baiting techniques, they managed to lure a giant squid to the surface. As the camera rolled, the squid, still very much alive, wrapped itself around the bait, its arms and tentacles flailing with terrifying strength. For a few short minutes, the Kraken was real, moving, reacting, fighting. Then, as suddenly as it appeared, it vanished back into the deep. The footage stunned the world. It wasn't a myth. It wasn't an exaggeration. It was here, in motion. A creature long confined to the edge of imagination was now fact, and what we saw only deepened the mystery. Architeuthis is unlike anything else in the animal kingdom. Its eyes, up to 30 centimeters across, are the largest of any known creature. They are designed to detect even the faintest glimmer of light in the darkest depths. They can spot the shimmer of bioluminescent prey, or the silhouette of an approaching predator from hundreds of meters away. Its arms are lined with suction cups, some ringed with tiny chitinous teeth. These hooks can leave scars on sperm whales, the squid's only known predator. Its body, soft, boneless, and streamlined, can contort through narrow spaces, propel itself backward using jet propulsion, and vanish in a blur of ink and motion. But for all we know, so much remains unknown. Giant squid remain almost impossibly elusive. They live at depths of 300 to 1,000 meters, too deep for sunlight, but not quite as deep as the abyssal trenches. They seem solitary. They do not school. They do not surface. Their flesh decomposes quickly when brought to the surface, making autopsy a race against time. Their diet, while assumed to be fish and smaller squid, has never been directly observed in the wild, and their mating behavior remains almost entirely a mystery. Some theorize that the males use a specialized arm to insert sperm packets into the female's body. Others believe their encounters are violent, even cannibalistic. But no one has ever witnessed it. They remain shadows, ghosts, hints. One of the few places we glimpse them, other than through camera lenses, is inside the stomachs of sperm whales. These massive whales dive deep into the ocean to feed on squid. When they return to the surface, their bodies bear the marks of battle. Rings of scars, circular welts, some a foot wide. These are sucker marks, wounds left behind by desperate flailing tentacles. From these scars, scientists estimate the squid's size. Some suggest they can reach lengths of 13 to 15 meters. Others believe there may be larger still, giants we have never seen, whose arms coil like living cables through the dark. But if that's true, where are they? Why have we only ever seen the smaller ones? Are the truly massive squid deeper still, below the reach of our cameras? Or are they simply rare? Ghosts among shadows? In recent years, marine biologists have developed new methods to track deep-sea cephalopods, including baited deep-sea drones and specially designed submersibles equipped with low-light cameras. In 2012, a team from Discovery Channel and NHK Japan captured the first high-definition video footage of a giant squid in the wild, not near the surface, but in its natural habitat, nearly 2,000 feet below the waves. The footage was haunting. A shimmering figure, gold and silver, slowly undulating through the black. It didn't attack. It didn't flee. It simply drifted past, as if acknowledging us and moving on. That's the enduring enigma of Architeuthis. It is not a monster. It is not a predator in the way sharks or orcas are. It is something older, more careful, perhaps more intelligent than we dare admit. And if the giant squid walks the line between myth and reality, there's another even more elusive cousin that steps fully into the unknown. The colossal squid, Mesonicoteuthis hamiltoni, is heavier, bulkier, and possibly more formidable than the giant squid itself. Only a handful have ever been found, mostly in the frigid waters near Antarctica. Their arms are shorter, but lined with swiveling hooks, some with razor-sharp edges that can rotate 360 degrees. They are stronger, more compact, more dangerous, and even less understood. If the giant squid is the Kraken of Norse legend, then the colossal squid is something even darker, a nightmare wrapped in soft flesh, drifting just out of sight. But none of these creatures, giant or colossal, have ever attacked a human. No shipwreck has ever been confirmed as the work of a squid. No diver has ever been dragged into the depths by those hooked arms. Which raises a question. Where did the fear come from? Why do we imagine them wrapping around our ships? Why do we draw them with red eyes and writhing limbs, dragging galleons beneath the sea? Maybe it's because they represent something deeper than biology. Not threat, but scale. Not hunger, but the unknown. The squid, giant or otherwise, is an embodiment of what we don't understand. It hides. It waits. It thrives in darkness. It sees what we cannot, and leaves only questions behind. Even now, in the 21st century, we still haven't found a live, colossal squid in the wild. We've never seen a giant squid hunt. We've never witnessed them mate or truly interact. For all our progress, they remain unanswered, which means the Kraken, in a way, still lives. Not as a beast bent on destruction, but as a question, as a presence just beyond reach, a reminder that the ocean, even now, is bigger than our instruments, deeper than our knowledge, older than our maps. It cradles these beings. It shelters them from light and from us. And when we do glimpse them, when the veil parts for a moment, we don't get answers. We get awe, a flash of movement, a blur of silver, a wound on a whale, a whisper from the dark. And so we drift onward, deeper still, carrying the memory of the Kraken not as a monster, but as a truth too vast for surface minds. Because not all legends are fiction, not all myths are wrong. Some are simply waiting. And somewhere below, in the cold halls of the midwater, a pair of eyes the size of moons may be watching us even now. Still, silent, real. Story 15. The Legend of the Megalodon. From the Kraken's silent domain, where tentacles drift like whispers through ink-black water, our descent continues. But not all leviathans of the deep werehooks or shimmer with alien light. Some haunt us not with glimpses, but with absence. For in the deepest parts of the ocean, where human eyes have barely lingered, another legend persists. It does not thrash or screech. It leaves no bioluminescent trail, no glowing eyes in the dark. Instead, it waits in the corners of imagination, in blurred sonar pings, in the unexplained scars found etched into the bodies of whales. It is the shark that should not exist, a predator from a time before man, rumored to endure still, hidden in the abyss, the Megalodon. Let's dive into the enduring myth that the largest shark to ever live may still be down there, concealed in the cold folds of the Mariana Trench, and why, no matter the science, the world cannot let it go. The Mariana Trench is not just a place, it's a refuge, a vault sealed by pressure and darkness, a final sanctuary for life that time forgot. Here, nearly 7 miles beneath the surface, temperatures hover just above freezing. The weight of the ocean bears down with 1,000 atmospheres of force, and sunlight, the great revealer, cannot reach. Only specialized submersibles and robotic probes have dared to visit this realm, and even they glimpse but fragments. We've seen strange things down here, creatures that glow, that fold inside out, that stretch their jaws like nets and pulse with alien rhythm, but never, officially, a shark longer than a bus. Never rows of 6-inch teeth. Never a moving silhouette so massive it casts its own darkness. And yet, the belief persists. The Megalodon, or Otodus megalodon, was the apex predator of its age. Its name means giant tooth, and that name is no exaggeration. These teeth, fossilized and serrated like blades, have been unearthed all across the globe. Some the size of a human hand, others as wide as a man's palm. They hint at a creature that could grow over 60 feet long, weighing upwards of 50 tons. Its bite was strong enough to crush a car. Imagine for a moment the power of such a beast. The oceans were its kingdom. Whales, its prey. No other predator challenged it. None could. And then, it vanished. By conventional science, the the Megalodon went extinct around 3.6 million years ago. Most theories point to a cooling climate, the decline of prey species, and the rise of modern great white sharks as possible causes. But the fossil record has gaps. And extinction, as many have pointed out, is not a visible event. It's a silence, an absence of further evidence. A curtain dropped without a body behind it. What if that silence doesn't mean death? What if it means concealment? The idea that Megalodon survived, hiding in the uncharted depths, has captured the public for decades. It began slowly, as all good myths do. A tooth discovered in a submarine trench, dated by some as only a few thousand years old. Sonar anomalies too large to be any known animal. Whales washing ashore with crescent-shaped bite marks the size of car doors. Stories from sailors of immense shadows swimming beneath their vessels. And surfacing never again. These stories, when stacked together, do something strange. They bypass logic and go straight to something older, instinctual. We want to believe in the predator we cannot see. And in the age of the Mariana Trench, we've found the perfect hiding place for it. The trench, after all, is not just deep, it is almost incomprehensibly so. Less than 5% of the seafloor has been explored with high resolution, and the trench contains countless side fissures, caverns, thermal vents, and crevices large enough to conceal not just a creature, but an entire ecosystem. If a megalodon had somehow adapted, growing more reclusive, hunting only in the deepest currents, would we even know? And if we did catch a glimpse, would we believe it? In 2013, Discovery Channel aired a mockumentary titled Megalodon: The Monster Shark Lives. It was framed as a scientific investigation, complete with staged interviews and fabricated evidence. Though the program was later revealed to be fiction, it ignited a firestorm. Viewers flooded forums, social media, and news outlets with questions. Could it be true? Had scientists covered something up? Was the Mariana Trench hiding a secret we weren't meant to find? The controversy didn't end there. In 2014, a video surfaced online claiming to show sonar readings from a deep-sea trawler off the coast of South Africa. The image displayed a massive moving object, roughly 60 feet in length, swimming at depths exceeding 4,000 feet. No known whale matched the profile. Was it real? The source was anonymous, the context vague. But that didn't matter. To many, it felt like proof. Then came the sightings. Fishermen in the Pacific reporting sudden losses of catch, lines snapped clean, nets shredded. Divers off the coast of New Zealand recalling enormous silhouettes that didn't move like whales or anything else. In one case, a recovered underwater camera, part of a private deep-sea project, showed a brief, flickering frame of something moving past the lens. Blurred, massive, with a trailing tail and a form that was unmistakably shark-like, but wrong. The image was dismissed as debris. Or was it? The scientific community has largely held firm. Megalodon is extinct, they say. The absence of recent fossils, or teeth, proves it. A creature of that size would leave signs. It would breach the surface at some point, leave carcasses, make noise, shed DNA into the water column. Besides, Megalodon preferred warm, shallow seas. The cold abyss of the trench would be unsuitable for such a species. All valid points. And yet, when James Cameron descended into the Mariana Trench in 2012, he spent hours exploring the trench floor and noted that the vast majority of the area remained obscured. His sub could only traverse a tiny portion, and the rest was shadows, unmapped, unexplored. What else is down there? Even now, New species are being discovered in the trench, some large, others bizarre, many unlike anything seen before. Is it truly impossible that one lineage, one survivor, could have endured? The idea isn't without precedent. The coelacanth was thought extinct for 66 million years, until it was found alive in 1938 off the coast of South Africa. The giant squid was long considered a myth, until footage emerged just 2 decades ago. Nature does not always make announcements. Sometimes it hides its masterpieces, and sometimes the legends are only waiting for the right eyes. Of course, there are problems with the theory. For a megalodon to survive at such depths, it would need to adapt to freezing temperatures, immense pressure, and the scarcity of large prey. Its metabolism would likely need to slow drastically. Its diet, perhaps, would shift to deep-diving whales or giant squid. Some propose that if a surviving megalodon lineage existed, it would no longer look like the surface-dwelling giant we imagine. It might be slimmer, pale from lack of light, its eyes larger, its movements slower. It might not breach the surface at all, only rising when the trench's tunnels funnel closer to the continental shelf. And when it does, what would we see? A shadow without a name, a wound without a witness, a myth glimpsed and then gone. In recent years, a few oceanographers have begun calling for more research into sonar anomalies in trench regions. Some advocate for deep DNA sampling in areas where strange sightings cluster. So far, no evidence of megalodon DNA has been recovered, but deep-sea currents move slowly, and some regions remain too remote to sample. One marine biologist, when asked about the possibility, said, "If a creature of that size exists in the trench, it's the best hider on Earth." And perhaps that's the secret. Not proof, not photographs, just absence, a kind of presence, by omission. We haven't seen it, but we haven't seen enough to rule it out either. And that gap between what we know and what might still be is where the megalodon lives, not necessarily in the trench, but in us, in our need to believe that something ancient and massive still watches from the deep, that we haven't conquered every corner of the map, that the ocean, for all our satellites and sensors, still keeps its secrets. There is something primal in the idea, something honest, a belief not in fantasy, but in mystery. We look at the Mariana Trench, and we don't just see geology. We see a hiding place, a realm big enough, dark enough, quiet enough, for the megalodon to still be real. And maybe that's what we truly want. Not the creature itself, but the space it represents. A reminder that the world is still wild, still unfinished, still full of monsters we haven't met. So when a whale surfaces with strange wounds, or a sonar ping returns something that shouldn't be there, or a diver hears a sound too deep, too slow, too massive to be anything familiar, we listen and we wonder, could there still be something down there with teeth like knives and eyes like voids, waiting in the folds of the trench? Science says no, but legends have their own gravity, and in the deepest waters of the world, where even sound moves slowly and light fears to tread, perhaps gravity isn't the only force at work. Perhaps something else stirs in the dark, still, silent, real, and somewhere, in the cold ink of the trench floor, something ancient may yet pass by our lights without a ripple, leaving only a question in its wake. What if it never left? What if the megalodon is watching us, waiting? The dragons and serpents of the ancient deep. We now turn our gaze to something older, something even more deeply rooted in human imagination. Long before we could send machines to the ocean floor, before hydrophones captured the cries of the abyss, we filled the silence with stories. Stories of dragons, stories of sea serpents, colossal eels, and gods who ruled the tides with thunderous wrath and jeweled tridents. Where modern science sees blackwater plains and tectonic scars, ancient cultures saw living chaos. Saw the ocean not as an ecosystem, but as a breathing god, one who swallowed ships, summoned storms, and hid monsters that stretched beyond the horizon. These were not mere tales told to pass the time. They were warnings, maps, prayers, and in the dark trenches of the Pacific, where even now our lights flicker out like dying stars, the ghosts of those stories still dwell. Let us now descend again, not in a submersible, but through memory, myth, and meaning, to the dragons and serpents of the ancient deep. In 13th century Scandinavia, sailors etched a warning into the margins of their maps: "Here be dragons." And while no fossil record links that phrase to a real species, its meaning is unmistakable. It marked the edge of what was known. Beyond that, only fear. On medieval portolan charts, one might find curling leviathans coiled around compass roses, scales painted in gold leaf, eyes wide and unblinking. Not merely artistic flair, they served a navigational purpose. A visual cue that this part of the ocean was unknowable, unmeasurable, perhaps even forbidden. And this cartographic habit was not unique to Europe. In Japan, ancient scrolls speak of Ryujin, the dragon god of the sea, who ruled from his palace beneath the waves, a hall of coral and crystal known as Ryugujo. He was no mere symbol of storm or tide. He was a force, a shapeshifter, capable of devouring fleets or calming tsunamis with a single blink of his serpentine eyes. His presence made the sea sacred, but also deeply feared. Thousands of miles west, the Hebrew scriptures recorded the Leviathan, a monstrous sea serpent so vast its coiling body formed whirlpools in the deep. It was said that only God could slay it, that in the end times its flesh would feed the righteous, and its skin would become the canopy of heaven. In Babylonian myth, Tiamat was the mother of all gods, and a dragon of the sea. From her body, the world itself was carved, the sky, the land, the oceans. But before creation, she was chaos incarnate, a serpent goddess of salt water who gave birth to monsters and struck fear into the very heavens. And yet, across cultures, a pattern emerges. These dragons and serpents of the deep are not demons, not evil in the Western sense. They are primal, powerful, unknowable. They embody nature not as a passive backdrop, but as an active agent, a thing that remembers. And in the Mariana Trench, we see their shadow still. The trench itself is a wound in the seafloor, a 2,500-mile gash slicing across the western Pacific, where the Pacific Plate dives beneath the Mariana Plate, driving rock and magma into unimaginable pressure. Here, at nearly 36,000 feet down, the water is so cold it approaches freezing, and the pressure is over 1,000 times greater than at sea level. No light, no warmth, only the weight of the world. It is the perfect place for a myth to hide. And in some ways, it has. Even in the 21st century, when we've mapped the surface of Mars in greater detail than our own seafloor, the trench remains poorly understood. Strange signals are recorded. Alien forms flicker past the cameras. Sounds without sources pulse in the dark. And with every unexplained anomaly, we find ourselves returning, not to equations or data, but to dragons. Because the dragons never truly left. In Norse legend, Jörmungandr was the Midgard serpent, a sea beast so vast it encircled the world. Ouroboros-like, it bit its own tail, and when it finally released that grip, the end of days would begin. It slept beneath the ocean, a threat contained only by its own inertia. And there's something haunting in that the greatest danger might not be a creature in motion, but one merely waiting, not attacking, not chasing, just existing, deeper than any hook can reach, just like the trench. Our ancestors knew the sea in ways we struggle to grasp today. They didn't just sail it, they feared it, not out of ignorance, but reverence. The sea wasn't a blank slate to be measured. It was a body, a mind, and every crashing wave was the movement of some enormous sleeper below. To them, a voyage wasn't just a route, it was a pact, with gods, with monsters, with the trench itself. And when something went wrong, when a ship vanished, or a fisherman never returned, they didn't blame weather patterns or magnetic anomalies. They knew what had happened. The dragon had stirred. In ancient China, sailors offered prayers to Ao Guang, the dragon king of the Eastern Sea, before each departure. His moods were unpredictable, his wrath legendary. Storms were not meteorology, they were punishment. Offerings were made, silk tossed into the surf, rituals performed on misty decks, sometimes, in whispers, even a life. These weren't metaphors, they were real acts done by real people who believed that the sea could hear, that its monsters could hunger, and maybe they weren't wrong. The modern oceanographer sees sonar returns and depth profiles. The marine biologist catalogues extremophiles thriving near hydrothermal vents. But these are not the only truths. Somewhere, in the curve of an eel's spine, in the flash of bioluminescent red, or the gaping jaw of a gulperfish, there is still dragon, still serpent. The trench did not empty itself when we named it. It merely shifted, waiting for the next story to find it. Consider the oarfish, the world's longest bony fish, a creature that can stretch over 30 feet long and has the body of a ribbon and the face of a fable. It rarely surfaces, but when it does, it thrashes in the surf like a prophecy. To the Japanese, its appearance has long been seen as a harbinger of earthquakes. They call it Ryugu no Tsukai, the messenger from the sea god's palace. And when a series of oarfish washed ashore in 2010, just before a major seismic event, the ancient stories surged back to life. Coincidence, said science. Warning, said tradition. And the trench remained silent. In 1857, off the coast of Portugal, the crew of HMS Plumper reported seeing what they described as a gigantic serpent with a mane of seaweed and a body like a railway car. It surfaced once, then vanished beneath the waves. Skeptics today suggest it may have been a whale or an illusion caused by converging currents. But the logs remain, and they echo the same patterns we see from Pliny the Elder to Polynesian lore. A great creature just beneath the surface, always near, never caught. In Micronesian myth, the god Olophat rode on the back of a sea dragon to trick his enemies and shape the islands themselves. In Maori stories, Taniwha guarded deep underwater caves, sometimes helpful, sometimes deadly. Each tale different, yet the shape is the same, long, scaled, unknowable. Serpents without start or end. Why do these creatures haunt us? Why do we place dragons in the water, when our skies too are vast? Perhaps because the sea conceals. It wraps its truths in darkness. We do not see what lives at 36,000 feet. We only imagine, and so imagination grows teeth. In 2014, a strange signal was captured by hydrophones near the Mariana Trench. It began with a low-frequency moan, rose into a metallic shriek, and ended in silence. The recording defied easy classification. No whale matched its signature. No quake aligned with its rhythm. Some called it the biotwang, others a mechanical anomaly. But to the myth keepers, it was something else. A breath, a stirring, a dragon, turning in its sleep. We like to think we've outgrown these stories, that satellites and submersibles have slain the monsters of old. But the truth is, we've simply renamed them. We say cryptid where we once said god, anomaly where we once said omen, species unknown where we once said leviathan, and the trench still listens. It holds our discarded fears like fossils in clay, waiting. So the next time a sonar scan returns a shape too large to classify or a noise too strange to chart, remember this: we have always filled the unknown with serpents, not because they are real, but because mystery is. And the Mariana Trench, cold, dark, and eternal, is not just a place where sea meets stone. It is a mirror, a reflection of what we do not know. And in that reflection, the dragons still swim. Story 17. The Unexplored Abyss, where mystery endures. From the dragons of ancient maps to the sonar pings of modern submersibles, we've always looked to the ocean as a canvas for our deepest fears and our most enduring fascinations. And yet, for all our stories, for all the names we've given its shadows, there is still one truth we cannot escape. We barely know what's down there. And so, from the coiled leviathans of medieval charts, we now drift forward, gently, slowly, toward a silence far more profound. Because not all monsters are named. Some are never seen at all. Now, let us descend into the unexplored abyss. It begins with pressure, the kind that doesn't just squeeze the body, but erases it. At the bottom of the Mariana Trench, over 36,000 feet below the surface, the weight of the ocean crushes down with more than 1,000 atmospheres of force. That's the equivalent of 100 adult elephants standing on your chest, or the weight of 5 jumbo jets pressing into every inch of your body. But at those depths, there is no body. Not really. Not as we understand it. There is no light, no warmth, no softness of touch or voice. Only cold, only black, only pressure. The kind that reshapes metal, that folds time into stillness. And that's where the mystery begins. Because in this impossible place, where water becomes something denser than we imagined, and where time feels fossilized in the silence, there is life. Life that glows, pulses, expands and shrinks, adapting not just to survive, but to remain hidden. It's often said we know more about the surface of the moon than we do about the deep sea. But that's not quite true. The moon, after all, doesn't change. It's silent, still, airless, frozen in time. The Mariana Trench is none of those things. It is alive, dynamic, shifting, and most of all, aware. In 2023, an expedition deploying a remotely operated vehicle to depths near the Serena Deep, the second deepest trench within the Mariana system, reported a previously unknown gelatinous organism. It had no eyes, no skeleton, no known classification. It responded to light by shrinking in on itself. When probed, it emitted a faint electrical pulse, like a Morse code in a language no one understood. The footage was reviewed again and again. Some suggested it was a siphonophore. Others said it resembled a comb jelly. But when cross-referenced with known species, it matched nothing. The team labeled it M. Trench Specimen Delta 4. That name has never appeared in peer-reviewed journals. Perhaps it never will. But the video is archived, blurry, strange, haunting, and it's not alone. For every successful dive, every sample returned, there are fragments, glimpses, movements just beyond the range of the camera, pressure readings that spike without cause, sonar returns that resemble nothing in the known marine index, signals lost, instruments jammed, or simply stopped. There are times when an ROV's lights flicker as if something massive passed overhead, though the sonar shows only the void. There are vibrations felt not as sound, but as a hum in the hull, felt by the crew as a kind of low, physiological dread. But dread is not data, and the trench keeps its secrets. We like to think of the ocean as mapped, that if a submarine went missing, we would find it, that if a new creature appeared, it would be catalogued, that if something was down there, something large, intelligent, ancient, we would know. But the numbers say otherwise. Over 80% of the ocean remains unmapped, unobserved, and unexplored. And of the deep ocean, below 200 meters, we've directly observed less than 1%. And the Mariana Trench? It has been visited by humans fewer times than the surface of Mars. Each descent takes millions of dollars, months of preparation, and equipment that can withstand the crushing weight of 1,000 oceans. And yet, even with the best technology, what we find is limited. A few hours of observation, some sediment samples, a glimpse of a translucent shrimp, and then the long, slow return to light. But light doesn't follow us back. It stays down there, in the eyes of the creatures that never rise. The first dive into the trench's greatest depths, Jacques Picard and Don Walsh aboard the Trieste in 1960, was a historic achievement. But it was also a mystery. When they reached the bottom, they reported seeing something that looked like a flatfish. This was impossible, or so scientists said. The pressure should have crushed any vertebrate. Bones could not endure. Muscles would liquefy. And yet, they saw it, or thought they did. Later reports downplayed the sighting. Today, it's labeled a misidentification. But that word, misidentification, carries within it a quiet assumption that the ocean cannot surprise us, that our models are complete. But the trench has other ideas. Because in 2020, a Chinese research submersible, the Fengtooths, recorded what appeared to be a large organism moving along the seafloor at a depth of nearly 10,900 meters. It had no fins, no tail, just a serpentine body that slid across the silt like a river of muscle. The footage was grainy. The lights reflected off suspended particles, and the creature, if it was a creature, moved slowly, deliberately, as if unbothered by the alien machine hovering above it. Then, it vanished into a fold in the terrain. No follow-up dive could locate it. The official report categorized the event as inconclusive. But among the crew, the term they used was different. They called it the rope, because of how it moved, because it didn't make sense. Speculation always fills the gaps. There are fringe theories, of course. Some say the trench is a gateway, a geological anomaly where time and matter blur. Others propose that deep-sea cryptids, unknown apex predators, have evolved in isolation, feeding on thermal vent ecosystems and avoiding detection through camouflage or silence. Still others lean toward the psychological, that the trench is not just physically crushing, but emotionally so. That prolonged exposure to its depths affects the mind. That sonar operators report dreams after deployments, recurring ones, of drifting alone in the dark, of being watched, of something enormous beneath them, coiled and waiting. These accounts are anecdotal, dismissed by most, and yet the dreams persist, and no two are the same. In 2017, a deep-sea probe called Echo 7 was lost during a descent to the Hossack Fracture Zone, an offshoot of the Mariana system. The last transmission it sent was corrupted. But within the static, a repeating pattern was identified, 6 tones, spaced evenly, followed by silence. The pattern did not match any known fault line activity. It was not a whale call, not machine feedback. And when the audio was played back through spectrographic software, it revealed an image, not literal, but visual in the way a heartbeat monitor is visual. The spikes were sharp, angular, almost like glyphs. No one knew what to make of it. The file was shelved, but researchers still refer to it sometimes in hushed conversations. They call it the call sign because it felt intentional. Even in more traditional science, the trench resists certainty. Xenophyophores, single-celled organisms the size of a dinner plate, live here. They are among the largest single-celled life forms ever discovered. They absorb heavy metals. They construct intricate structures from detritus. They are alive, fast, slow, and nearly immortal. Some have been found partially embedded in the rock itself, growing there, feeding there, waiting. And around them, other anomalies appear. Giant amphipods with transparent exoskeletons, eel-like fish that glow pink at the tips of their tails, octopus species with cartilaginous armor, moving with an intelligence that seems aware. These creatures do not belong to the familiar tree of life. They're offshoots, branches we never saw grow, leaves on the underside of the world. And if evolution can do that, what else can it do? There are places in the trench that no machine has ever reached. Canyons within canyons. Fissures so deep they fold back on themselves. Gravitational pockets that confuse instruments and swallow light. Some of these areas, when mapped with sonar, return strange echoes. Not shapes, not voids, but interference. Like static. Like something is reflecting the signal back not as an object, but as a distortion. We don't know why. We've labeled them acoustic anomalies. But one sonar technician, who worked aboard a deep-sea survey vessel in 2019, said something different. It wasn't a glitch, he said. It felt like a response. When pressed for clarification, he hesitated, then said, like it was listening. In the early 2030s, private deep-sea exploration began to boom. Companies seeking rare earth elements turned their attention to the trench floor, where manganese nodules and polymetallic deposits lie undisturbed. In 2034, one such expedition launched a drone equipped with specialized claws meant to extract samples without disturbing the delicate ecosystem. Midway through its descent, the drone's orientation shifted, violently, as if pulled. The telemetry was erratic, the arms activated. Then the signal cut. The drone was later recovered, crushed like a tin can. The data log was incomplete. The official cause, implosion due to uncalibrated depth pressure. But the engineers disagreed. The drone had been rated for greater depths, and the implosion point didn't match the design tolerances. The crushed body was kept, stored. No further missions were launched to that site. Some say the company buried the report. Others say they didn't want to disturb whatever was down there. If there is one truth the trench offers us, it is this. We are not ready. Not to understand. Not to explore. Not to see. The creatures that live down here, if they are creatures at all, have adapted to a world we were never meant to enter. They live without light, without air, without us. To them, we are anomalies, disturbances in the current, moments that come and go and do not return. And perhaps that is as it should be. Because for all our submersibles, our sonars, our equations and classifications, there is one thing we cannot account for: the unknown itself. We can name the pressure, measure the depths, plot the heat, but mystery does not care. It exists because it chooses to, because the abyss does not owe us revelation, only reflection. So what is the Mariana Trench? Is it a scar on the Earth's crust? A cradle for the oldest life on the planet? A vault of evolutionary secrets? Or is it something more? A reminder that our world is not yet finished, that not every chapter has been written, and that some things are meant to be questions, not answers. Because in the end, the deepest mystery may not be what we find in the dark, but the silence that answers back. And as long as that silence remains, the monsters of the deep, whether eel or myth, sound or shadow, truth or terror, will continue to wait. Not because they are hiding, but because we haven't learned how to see them yet. And the trench is patient. The ocean hides more than we'll ever truly know. Some of its creatures have names, others only shadows. And in the deepest parts, where pressure crushes and darkness reigns, the line between fact and folklore begins to blur. The mysteries we've uncovered today are just the beginning. A glimpse into the strange, the unexplained, and the terrifyingly real inhabitants of the trench. But for every question we ask, a dozen more rise from the depths. If you enjoyed this descent into the unknown, make sure to subscribe and explore our other documentaries, each one a new journey into the places science still can't fully explain. Thanks for watching, and as always, stay curious, stay safe, and never stop listening to what lies beneath.